Okay, let's get started. Hi guys, welcome to Zero to Hero Security class. This is Piotr speaking, and this is our meeting number 4. Let me share my whiteboard. Okay, here we go. And get rid of this guy. Okay, so that's the week 4. And today we're gonna switch the topic to the new one, and this is gonna be the firepower. Right, so I have a plan to start talking with some history of firepower. As you may see in a different documentation, that there are different terms related to the firepower, and sometimes they lead to the same thing, but you need to be aware of the old versus new terminology. And I think the best way to cover that topic is to give you a little bit of history lesson when or where that the firepower came from. Right. And then we're gonna be moving to the different firepower hardware that we currently have, the old and new models, how we can install the firepower, how we can use it, and then we move to the individual features, such as security intelligence or IPS and access control policies, and so on and so on. So the firepower is actually a big topic. I think we're gonna spend at least 3 meetings cover that. Okay, so yeah, let's get started. So let's save that. Or yes, let's start with a little bit of history. It all started in 1998 when Snort was the first developed or invented. Snort is an open source IPS IDS engine. It was IDS at the beginning, and then it migrated or evolved into the IPS. So for those of you who are not familiar with those terms, IDS is the intrusion detection system. IPS is intrusion prevention system. What's the difference? Basically, the system does exactly the same thing, but with IDS mode is just monitoring and alerting. Cannot actually stop any attack, and IPS is more active. So prevention stands for, it can stop the attack when it sees it. So nowadays we usually have IPSs, but the IDS, it's still a mode that we can run IPS into. If, for example, you are in a situation or you want to put an intrusion prevention system in some critical network, but you're worried about its it's not becoming the bottleneck in the network, then you may decide to deploy it as an IDS. So it's looking into the attacks, but it's not doing anything by that. It's just a monitoring system. Anyways, the Snort is the one of the most successful open source IPS RDS projects. It was invented by Martin Roche. This guy is actually now working for Cisco, but back in time, it's obviously he wasn't working for Cisco. He was just the guy, the developer who started doing this, and that project was pretty successful. You can imagine in 1998 there wasn't a lot of attacks, network attacks, or bad things happening. But they started, and it was quite successful. The community around this project was pretty solid, and a lot of people were helping testing, developing, co-developing, and doing stuff with the project to make it better. So Martin started thinking about making some money out of it, but obviously how to get money from the open source project, it's hard, but you can close it, start selling it, or you can start selling some additional services around that. So Martin did that actually in 2001. Yes, it is still open source. Yeah, that's a good question. Yeah, even though formally I think it belongs to Cisco now, but it's still an open source project, and anybody can use it. In 2001, Martin founded a company called SourceFire, right? And he thought, okay, I will still keep the Snort open, but a lot of people is asking me how to can I help with configuration, deploying, and so let's offer that. So instead of just giving them the software for free, we can give them a full working server, like appliance, right, with Linux on it, plus Snort, already configured and deployed. Because Snort, a lot of people have problem even today to run it, because it must be compiled from sources, must be the server must be protected as well. So maybe it's better for such people to just buy an appliance, something that is already set up. So Martin start with this service, and actually they call this Linux. At the first time it was just a Linux with a Snort on it, but then it was evolving to more like an appliance with some software on it. And this software, this Linux underneath and a Snort working on it, they called it Firepower. Let me change the color, maybe Firepower with a capital Power. Okay, that's important. That's why I'm telling this. Now we call it just Firepower, lowercase, and that's also important. I call it FP for short, but you can just call it Firepower. Another thing that he started offering was the management appliance, right? For people who have a need for more than one Firepower system in the network, it would be really nice to have some GUI, some graphical interface, some centralized manager to centrally manage different Firepower boxes. So they created a new piece of software, also based on the Linux, that was able to manage the firepower or firepower software or firepower appliances. And they called that Defense Center. Okay, Defense Center. Or DC. Obviously, DC, if you think, if you look at this acronym, you always think about Microsoft, not the Defense Center. So they changed that name actually to later to the Fire Site Management Center, right? Or FMC. Now we call it Firepower Management Center. It's a centralized manager. Acronym is still the same, FMC. Right. So from what is current is here. This is the firepower. The appliance firepower management center is the current name for manager. And later, during the evolving process of the company, they started thinking about adding new features. And there was one feature that was, I think, it was a game changer for that company. They invented something which is really, really cool, and it's still making that SourceFire and now Cisco Firepower is still #1 in IPS world. They call it RNA, real-time network awareness. Real-time network awareness. Right. Then they changed the name to Fire Site. For that, I will tell you in a second what's this, Fire Site. That's why the name for a manager was the Fire Site Management Center. Now we just call it Network Discovery. Maybe let me put that in blue. Network. Okay, someone's not. Okay. Network Discovery. That's the official name for this technology. Okay, what is all about? If you have a firepower system running on that appliance in network, and you have that between client, you see the client to the server traffic, right? When the traffic goes through, the system, the firepower with the network discovery enabled on it, tries to passively check or notice what's on the client and what's on the server. And it's creating something called a host profile for a client and the server, for any IP address actually. Okay, what's the host profile? Everything that was discovered. For example, obvious thing, the IP address. Let's say this is the 10.1.1.1 IP address for a client. Operating system. What is the operating system on the client? For example, Windows 7. How Firepower knows what is the operating system? No, it's using the passive OS fingerprinting. The same thing, like you have Nmap, and you're trying with an Nmap a scan for a host, and you're trying to guess what is the operating system on the host. So based on a TCP stack and how packets look like and how the TCP stack behaves, we can guess what is the operating system. Okay, so different operating systems, they have different stack for TCP/IP. So Linux is completely different than Windows. Different Windows versions are might be different from each other. So we can guess this way what is the operating system. Also, if we see some application traffic, we can get that information from maybe from I don't know, HTTP user agent, stuff like that. Okay. So also we can or the system can discover applications, like client applications. So for example, Firefox, I don't know, 60. There is a Firefox 60 running on a client. How we know that? From the user agent, most likely. Or Internet Explorer 6, which is the old version. Then you can make a decision to take a look at this host to not use the old Internet Explorer. Services. Like on TCP port 80, we see that there is an Apache running. Okay, so we can guess what are the services on the host. Now, why this feature is so important and why it was the game changer for IPS? Because based on what was discovered on the host, we can map potential vulnerabilities to that host. Right, so for example, I see that there is an Internet Explorer 6.0, so I know that there are some vulnerabilities like this affecting the Internet Explorer 6.0. Right, I know that there is a Windows 7, so there are some vulnerabilities for Windows 7. There is other Apache, maybe 2.2. There are some vulnerabilities for Apache. It's based on a CVE, which is the common vulnerability database that we that we have on the internet, and this is a database with a known, already found, confirmed vulnerabilities. So once we match those vulnerabilities to the host, right, we can use them later to help us tune up the IPS policy. Right, so if it comes to the IPS tuning, IPS is just a bunch of signatures, right? So let's say we have 30,000 or 35,000 signatures. Now it's all nowadays it's almost 40,000 signatures, and we usually don't have enable all of them. We just enable some of them that are relevant to our network. So it would be really nice that in the ideal world, we have only those signatures enabled that are really relevant to the vulnerabilities that we currently have in our network. If we have too many signatures enabled, that will cause a lot of false positives. A false positive is a situation when there was no a real attack, but there is an event or alert saying that there was an attack. Okay, and it keeps us busy, net security analysts, security administrators, busy to understand what's going on. Is it a real attack or it's not a real attack? So we don't want to have a lot of false positives. That's gonna kill us and our productivity. So probably less events is better, right? But we only want to see the real events. So if we have some vulnerabilities and we have only those signatures enabled for those vulnerabilities that we have in the network at the now at this time, then we will only see the relevant alerts. Okay, and that's a really, really cool thing, because what is the nightmare of the IPS administrator or security analyst? Too many false positives. And that was the really cool technology that will allow us to limit the number of potential false positives to the minimum. Okay, so the host profile network discovery is just something that will help us to limit those false positives later, right? So network discovery data is obviously nice to have. So I know what is on what host, but I would also need to use that information to tune up the IPS. And we will be doing this, probably not today, but next week, when I will be talking about IPS. Then we will be tuning the IPS signatures based, or yeah, the IPS policy rather, based on the network discovery and the vulnerabilities that we have in host profiles. Okay. So what are the features added to more features added? Example, next generation firewall rules. What's this? Next generation firewall. What's the next generation? Everybody says that everything is next generation nowadays, right? So it means that we don't just have a firewall, typical firewall, layer 3, layer 4, like ASA is, right? ASA is just a firewall up to layer 4. We can filter traffic based on IP addresses and ports. So there are some limited options to do something more than this, to go to the layer 7. For example, MPF, the modular policy framework that we talked about, allows us to take a look into the layer 7. But basically, ASA is just a layer 3, layer 4 firewall. But next generation firewalls, they usually have more than this. They have application detectors. And this is exactly what we have here. There are 3 types of applications here. So what we can detect. There are more than, I think it's more than 3,500 application detectors now in the system. Protocols. A protocol can be an application like HTTP, FTP, right? Remember the problem that we talked about, the problem with passive FTP working on a non-standard port on the ASA. We had to tell ASA that there is a different port used for our FTP server. Now, using the application detector, we don't need that anymore, because the application detector will find out that this is the FTP traffic, right? So it will automatically open up the hole. So protocols. Then web applications, right? Like Facebook, right? We have Facebook, Twitter, Google, those big players. They created applications, but based on the web. So even the Facebook is not just the one application. It's not just the one website. There are a couple of sub-applications on the Facebook. We have Facebook games, Facebook video. We have Facebook chat, Messenger, right, and others. So we can control with application detectors. We can detect and control those web applications now. And 3 is the client application. Client applications, like I showed you here in the host profile. Right? The Firefox is the client application. Internet Explorer is the client application. PATI is the client application. So you can potentially create a firewall rule saying, I want to block everybody that is using Internet Explorer as a client application. So only the Firefox and Chrome will be able to go out, but if someone is using Internet Explorer, that's going to be blocking him. Okay. Plus, obviously, the next generation, generally, next generation firewalls have also another security features on them, like IPS is one of that feature. We have IPS because the snort is there, obviously. The snort is the core, is in the core system. What else? The URL filtering. The URL filtering was added along the way. It's actually not the homegrown solution. It's the OEM from the Bright Cloud. The URL database comes from the Bright Cloud. Okay, now it comes from Cisco. Okay, because Cisco, after buying this SourceFire, migrated that, but not straight away. It was using the Bright Cloud till 6.4 or even 6.5, I think. Now in the latest version, the database is from Cisco, not from the Bright Cloud anymore. But the URL filtering, how that works. The URL filtering is something that will allow you to use URL categories in your firewall rules, right? So, for example, you can block some categories you can block the shopping or block the porn or gambling, right? Categories based on the URL filtering. But URL filtering is pretty, I would say, weak as a security feature because less than 10% of global URLs are categorized, really. URL filtering databases on the web. What does it mean on the web? Oh, it's the database is downloaded to the manager and pushed to the device. So it's actually we're downloading the URL filtering database from Bright Cloud or from Cisco, and we use it locally. But as I said, I think the URL filtering is not really a good, the best feature for security, for web security. It's something that will give you some just the basic filtering functionality. But as I said, less than 10% of URLs are categorized. Most of them are being well-known sites. If you are looking for something which is malicious, you will not have that categorized. It's like malicious sites are not there. So you cannot treat it as a real feature that will give you the whole, a lot of security confidence. Actually not. And I can also say here that I always say to my clients or people that I'm talking with around the URL filtering, I would never recommend of exchanging or swapping the current proxy to the firepower with URL filtering. I know there are some people that are thinking this way, that they think, oh, we have that proxy, now it's doing the URL filtering, but you know what, the new firepower has the URL filtering, so maybe if we are migrating to the firepower, then let's just add this URL filtering license and scratch our proxy. And this is really, really bad idea, in my opinion, because proxy is way more than just a URL filtering, a good proxy, right? So a URL filtering is just a small feature that will give you the ability to filter out the obvious things. But if you're looking for something more dangerous, this is not going to be in the URL database anyway. So a proxy is usually way more advanced. It can give you some more engines, can scan the content for additional things like JavaScript, CSS, stuff like that, and can block based on a different other reasons, not only the URL. So never think this way. Never exchange your current proxy solution with a URL filtering on a firepower. And to be honest, if I may say that I treat the URL filtering on a firepower not really reliable. And maybe nowadays it's a little bit better, but I'm with this firepower boxes, I don't know, since Cisco acquired that, so it was 2013, 7 years now. And I can tell you that the URL filtering is really not that reliable like you would like to have it. So I would not use it as a basic, or basic it's still fine, but as a main security feature on this product. Phil is asking, is the URL database shared or sourced from same entity as Palo Duvet? I don't know what is the source of URL filtering for Palo. Cisco in the firepower now using the Cisco's URL database, which is also coming from the acquisition because Cisco bought an iron port company a couple of years ago, and the iron ports database, URL database, is currently used on the firepower. Cisco use Talos and number. Yes, yeah, we're gonna talk about this later. But Talos is basically a team. Okay, it's a team of people that are doing research, and they are maintaining and updating all the security, cloud security intelligence that the Cisco has. For example, the AMP cloud, the umbrella, they are sharing the threat intelligence with all those platforms. So firepower can also utilize that in some places. For example, in AMP solution, or with a sandboxing solution like ThreadGrid. So there's no, I wouldn't say that the Talos or something like that is a feature here. No, it's just the feature is anti-malware is the feature that can utilize Talos intelligence. Okay. They also added some VPN features to the original appliance here, but I don't want to even put that here on the list because you may be, it may tell you that, okay, the VPN is the current VPN that we have, the current VPN feature that we have now is this VPN. No, this is the old VPN that was developed by the SourceFire, and it was just side-to-side VPNs between appliances. So shouldn't really put that on the list. Okay, What else? In 2011, SourceFire was quite successful after those 10 years as a typical IPS. Right till then, SourceFire was just an IPS, I would say. Most people were thinking about SourceFire appliance as a IPS, not as a firewall. Okay, and 2001, they decided to acquire a company to get something or to get some additional features. And they acquired a company called Immunet. Immunet company was just a startup, I would say, or yeah, it was a small company. It was a company that invented and created AMP. The AMP is the anti-malware protection in the cloud. So it's not really the typical antivirus or anti-malware solution that we know of. Like we have a kind of anti-malware agent running on the local box, and we can download signatures, and then if we download a file and this file is malicious, then we can block it. So it's no longer this approach. Now the approach is it's a different approach. It's a cloud approach. So which means that the AMP is just a cloud-based solution, and we have just a small agent running on a host or on a network device like Firepower, and this agent is just taking the file, making a hash out of it, and asking the cloud for a disposition. When Cisco bought Firepower, no, not yet. It was 2013. Okay, so this is a cloud, AMP cloud, right? And we have here on the endpoint or on a Firepower, we can talk to the cloud and ask the cloud if this what we see is malicious or not. We'll be talking about that solution in a very details, so no worries. Okay. So after acquired that company, they called this solution Fire, or this feature Fire AMP. Now we call it just Cisco AMP after being acquired by Cisco. OEM, oh God. I know OEM means that you're just buying this from somebody else and reselling. I'm not sure what the OEM really means. This acronym. Someone can Google for it. Oh, original equipment manufacturer. Ah, thanks. Thanks, guys. Yeah. And finally, in 2013, Cisco acquired SourceFire. Right, and straight after that, Cisco started to implement what they could in their products. So for example, the easiest one was the AMP, because AMP was just a piece of software, piece of agent that must be running on a hardware or network device and ask the cloud for a disposition. So it was the easiest one. So AMP was the first really to be implemented. They added AMP features on a WSA, Web Security Appliance, and ESA, Email Security Appliance. They also added on the ASA the firepower. So if you had ISA 5500X, you can put 120 gig disk SSD into it, and you can install the other way. You can install firepower on it. Okay, so that was the easiest way to start the integration. And I must say that was a really good decision. If I take a look at that from a time perspective, at that time I was really surprised, like not shocked by this decision, because Cisco bought a company that basically produces the same things that Cisco did, right? Cisco had its own IPS portfolio, actually quite a new portfolio. Obviously, the Cisco never been the number one in the IPSs. That's okay, right? But they had the whole portfolio of products, and they scratched that from one day to the other and replaced by SourceFire appliances. That was one thing. Another thing was the firepower on the ASA. Cisco was developing for a couple of years at that time, I think 2 or 3 years, a new product called ASA CX, and it meant to be a next generation firewall. And they scratched that product as well. And instead of that, they started selling firepower. So basically, they replaced their products with the same functionality products coming from the acquisition. But from business perspective, I think it was a good decision, because there was a lot of new things happening, especially at the business level, and and a lot of fresh blood. Martin Roche, the guy who owned SourceFire, joined Cisco, and he became a very important guy in the security. He started dealing with much bigger security division now, and started looking into the future. It was, I think, a very good decision. And the only thing that you may heard that the firepower itself was not that good at the beginning. Now it's much better, I would say. They migrated at Cisco, being at Cisco already, they migrated from 5.4 version to 6.0, and that was it brought a lot of troubles, basically saying. Now it's much better. The problem was not that the product is crap. The problem was with a scale, I would say. Because if you think about SourceFire being a typical IPS and maybe a little bit of the firewall company, smaller, much smaller than Cisco, they had smaller clients also. And now when Cisco acquired that, started selling the same product that was quite suited to smaller customers, they started selling this product to big customers or much bigger customers. Then the scalability and performance issues started arising, and that was the problem, in my opinion. Now it's nowadays it's pretty good. definitely much better than it was 2 years ago. But it took time, and I think Cisco lost its momentum a little bit because of that. So that's my honest opinion about it. But the product itself, I think it's great. But you need to understand the history and how it was, what was the reason why this product had a bad words in the past. Is AMP a replacement for antivirus? That's a tough question because the answer is yes and no, depending on how you would like to approach. We will be talking about this later, but the quick answer from my experience is yes. Sure. Real-time network awareness is the network discovery, the feature that will take a look at the traffic that is going through the device, and it's building the host profile, learning about, based on a traffic that it sees, it's learning about the traffic, learning about operating system applications, services, and all that stuff. Okay. We'll be talking about that in more details. Yeah, it's not a scan. It's a passive. Yeah, scan is like someone is scanning something, right? Okay, you may think about this like a scan, but it's not actively scanning anything. It's just passively, it's seeing the traffic and looking into the traffic and learning about it. Yeah, so you can call it passive scan. Not antivirus. No. Okay, there are different terms. We don't have antiviruses nowadays. Everything is anti-malware. Because nowadays we talk about malware, and one of the malware kinds is a virus. Virus, worm, Trojan, all that stuff is now malware, considered malware. So there is no difference between, okay, it doesn't mean that the anti-malware solution has no antivirus solution in it. It has. Yes, now it's more like EDR rather than typical anti-malware solution on a box. Yeah. Okay, let's move on. We'll be talking about all those things um, in more details. Okay. What is rank on a Gartner? I don't know. We'd need to check that. I'm not in sales, so I don't need to bother. I'm more a technical focused guy. Yeah, guys, so what are the devices? So we have two type of devices. We have something called a managed device, and that's actually our firepower device. And we have a manager, right? So this is the firepower, or FP, I call it for short. And management is the FMC, the Firepower Management Center. Now we can have a different hardware that we can run software on it. So we have a hardware appliances, The old ones are 7 or 8,000 series. 8,000 series. I don't think they are still selling them. I'm not sure. I need to check that. Might be. If it comes to the software, okay, so that's gonna be the software column. We have firepower on it with a capital power, because this is considered a next generation IPS. What is the next generation IPS? So the next generation IPS is basically everything that came from the source fire, like snort on it, the next generation firewall rules, application detectors, maybe AMP with it, all that stuff, and our network discovery to help us tune up the IPS. That's the next generation IPS. And we still call it the firepower with a capital power. Okay, that's why I said that this is there's a difference between firepower lowercase and firepower capital. And we'll get back to that in a second also. And there are new appliances called FP 9300, FP 4100, FP 2100, and FP 1000 or 1100. Those are the new platforms that we can run firepower on. But those platforms support a little bit different software, firepower software. There is no firepower capital power anymore. This is the firepower NG firewall, which is sometimes people call it FTD. So FTD is a software that came from a merge of two softwares. ASA operating system, the ASA software, plus firepower software merged together in a one code. Okay, so this is a one code. We call it Firepower Threat Defense, FTD, or actually the official name for it, because that was the first name that they started using to describe this one code ASA with firepower. Official name for that is the Firepower NG firewall. Okay, so it's a different software than this. This is the next generation IPS. This is the next generation firewall. Remember, this is a different thing. Also, as a hardware, we can use ASA. Right, so all models, ASA models with -X, basically can handle that. So 5500-X, when basically the 00, it means it's going to be 25, 45, 55, right? If you put a 120 gig disk SSD into that hardware, you can run firepower on it. But now, here is the ASA operating system. Here is the firepower, the code, the next generation IPS, the code that we got from the source fire. Okay, remember about that. It looks like this. If you have ASA hardware, right? ASA is running here. the ASA software is running here. You have that disk. On a disk, you install the firepower. Okay, and you basically configure ASA to redirect the traffic to the firepower and then send it out. Okay, so this solution is still using the old firepower next generation IPS software. Right? There is also ASA 5585, which is end of sales now, so I don't want to talk about this even. We have 5506, 08, and 16-X. Those things are a little bit different. They have different kind of different architecture. Let me check in the chat because there's something happening in the chat. Well, we can get rid of ASA code and put, yeah, we can put FTD on it, right? Yes, obviously. Okay, but I'm talking about this situation here. And 5506 is quite nice to see because it has a call it built-in or on-box FMC. On-box FMC, which means that firepower can run on it, plus the manager is running on it. And this is the smallest ASA, so it's quite amazing how it is possible to run the manager on that box. But there is a limit. There is a limitation when you do that. The limitation is there will be no network discovery. No network discovery. Okay, if you run it on box, but you can still connect that to the centralized manager. We call it off-box FMC, and then you have all the features back. Okay, when FMC is separate, right, like off box, then all features are available. And so you can decide. Yeah, let me really talk about this as well, because ASA, those models can also run FTD. Right, so if you have FTD, you basically say, okay, I don't want to use ASA software anymore. I want to put FTD on it. It's like this. FTD is being installed on that disk, but it's like owning the whole hardware. Now, okay, so firepower, ASA OS plus firepower, or ASA plus FTD, ASA hardware plus FTD software on it. That's the way to show that. The two flavors with the ASA. You can still run ASA as a separate software plus firepower on the disk, or you can just, re-image the whole ASA with just FTD on it. From the features perspective, okay, there are a couple of differences here. Because FTD, even though it's a combined software, ASA with firepower in a one code, it's still not supporting all features that we had on the ASA alone. So we'll be talking about that as well in a second. And finally, we can have a virtual version of the managed device. We can run it on the ESX, a KVM. We have it in our lab. We'll have it in our lab running on the ESX, KVM, AWS, so Amazon Web Services supported, Azure supported as well. And here we have two options to put. We have NG Firewall Virtual, or which is basically the FTD, or next generation IPS, which is virtual, which is exactly the same like you have on this disk on the ASA or on the all old appliances. For CCIE, what is the lab based on? I think ASA with FTD, or FTD virtual, because I would think that they keep the ASA to have ASA on it. So it's for me it's more like the virtual version of the FTD. FTD virtual, this one, NG Firewall Virtual, and ASA will be still there to test you on things like clustering, active-active failover virtualization on the ASA hardware. Okay, and the management. Right, so for management, we also have a hardware appliances like FMC. Oh God, I need to check because that's changing a lot. So I need to check that really. Yeah. Let me share that with you guys. Right. So we have FMC 1600, 2600, 4600 now, because they are based on the new UCS models from Cisco M5, I think. So we have FMC 1600, FMC 2600, and FMC 4600. Those three appliances, and we have virtual. Obviously, the bigger appliance you have, the more events or the sensors, they call it sensors, you can manage, right? So manage device. So 50 in 1600, 300 sensors managed in 2600, 750 in 4600. And obviously, plus the number of events that can be stored and host profiles that can be stored, right? So number of sensors is the limit. Right, here we have 50. Check that. 300, 750. 300 and 750. With a virtual, they say on the website, notice that this is the 25, the number is. Actually, it's more than this, because the virtual appliance, I believe this is the best solution to use the virtual one. Because if you use the hardware appliance, then you would need to have at least two appliances to have high availability. it's difficult to manage. I mean, to operate when something goes wrong. If one of them dies, you need to restore from a backup. That's quite, cumbersome, I would say, this process. It may not work well as well. So for example, the backup, you can backup the system, but you cannot restore sometimes. I know such histories and stories, I mean. And what else? I would basically go to the virtual. Virtual is easier to maintain because you run it on ESX. You can do the snapshot. You can, before, if you upgrading it, you can just do the snapshot, then upgrade. If something goes wrong, you can restore from the snapshot real quick. You can have only one of them if you have correctly, deployed the virtual infrastructure. You have vMotion stuff like that. Then it's only one that is really needed. The thing is that 25 sensors are supported in that virtual version, and that might be the limit. That's why in the latest version, they increased that limit to 300. And this is official. So you can actually now run the virtual version of the FMC and manage up to 300 sensors, which is a lot. Let me check the chat. So for the ASA and FP, do we need to configure ACL 2 times or yes? If that's the ASA plus FP, yeah, you have the policy in 2 places. We'll be talking about that later. Okay, software list. Heard that if you use AD or TrustSec integration and you create ACP like deny user, how they will, I don't know. We would need to check that. Right, so this 300 sensors, even though it says 25, if you really go in deeper into that, not that obvious, but if you go deeper into the data sheet, is the FMC, they are still showing 25 as a maximum number of sensor managed, but there is a little bit of asterisk here, which is saying, okay, so this is a software, come on, where is that? It was here. Maybe they get rid of that information. That would really be something. Pretty sure that it was. I was checking that maybe, I don't know, a month ago or 2 months ago, and it was 300. If you run it on a correct hardware, if you allocate. Yeah, I'm a bad salesman. Yeah, that's why I'm not in sales. But yeah, I'm pretty sure it was there. I will check that because it looks like someone get rid of that information from the datasheet quite recently. Okay, that's interesting. Oh, Niket found something. Virtual getting started guide. Yeah, FMC 300 for VMware. A new scaled VMC V FMCV image is available on VMware platform to support managing of up to 300 devices. Yeah, thank you for that. Yeah, so yeah, it was there. That information was there in a data sheet, but for some reason, maybe they don't want us to know about that. I'm not sure. Yeah, that's the 6.5. From the 6.5, it was tested and officially supported. Yeah, it may require a lot of disk space, but even with those hardware appliances, you have that space, and you need to give it that space for events. Yeah. Okay, so you can run this virtual version on ESX or on KVM. Second. Interesting. Yeah, as you can see, you can also run it on Amazon and Azure. That is also something new because it wasn't supported before on AWS and Azure. Okay, let me put that info that this is from 6.5 version. Right, and there is also another thing. There is a cloud solution for management called CDO, which is something which is quite new. Cisco Defense Orchestrator. But I wouldn't go for that option now. I would wait a couple of months because it's still, I would say, under development. But yeah, the plan is to have it managed in the cloud as well. Okay, so basically, if maybe that's not clear enough, if we take a look at the firepower software again, we have basically two softwares. We have NG IPS or firepower with a capital power, or NG firewall, right? Or firepower, or FTD. Those are the names, right? The firepower NG IPS is supported by old firepower appliances, or ASA plus firepower on disk. Okay, those two places, or virtual NG IPS. That's also a possibility. The NG firewall, all right, is supported on new firepower appliances like 9300, 4100, 2100, and 1000, right? Or on ASA. But you need to re-image the whole box. Okay. Now I think it's clear. So the way to go is actually this one. Okay. If you would like to reuse your current ASA hardware, you can still do that. Okay. But if you are trying to, or you're thinking about replacing your old ASA with a new firewall with firepower on it, then the way to go is the new firepower appliance, one of these here. Okay. From the manager's perspective, it's a little bit more complicated, I would say. Because okay, the problem was like this. We had ASA with firepower on a disk. So we had two managers, right? ASA could be managed with CLI or ASDM, right? Firepower must be managed by FMC, right? So problem is two managers. That was the biggest issue here. So as someone in the chat said that, in this case, when the traffic comes to the ASA, it hits the ASA's access list, and then it can be redirected to the firepower, and there is another policy that you need to manage. So you're managing two policies separate with two different managers, which is quite, not nice, right? Not cool. That's why they decided to merge those two softwares to have all those features from ASA and features from firepower in the one software, right? Then they migrated to FTD, right? So you have ASA features ported to the firepower software. Okay, so now you have only one manager. You're managing this with FMC, but not all features from ASA are ported to the firepower software. So it means even though actually there are almost all features because the code is there, but the problem is that the manager is not ready to configure that code. So there is no GUI to manage the ASA, some of the ASA features. Yes, exactly. That's the problem, right? Too. No CLI. No CLI. Actually, the CLI is there, but read only. I mean, you cannot configure. You cannot go to the conft and then configure some access list. No. You can just configure some basic things. Yes, API is there, but you're not using this API directly on the FTD. You are using API from the FMC and to manage the FMC and deploy the changes to the device. Okay, so you never directly manage the FTD with something else than FMC. Is FMC based on CSM? That's a very good question, and I think that you are worried about that. I would do as well. Yeah. Okay. So the answer is yes, a little bit. So when we take a look at the firepower threat defense FTD, you'll see that when you push a policy to the FTD, you will notice that the access list there is having a name with a CSM in it. So yes, basically they used a little bit of CSM's code to put that on the FMC to manage the ASA related features. That was the thing. Yeah, exactly. So this is a Cisco Security Manager. It's a centralized manager for multiple ASAs. If you have ASAs and security on routers and IPSs, Cisco IPSs, the former Cisco IPSs. Right, so that's the CSM. Okay, so now we have a couple of managers actually. So they wanted to limit the manager to only one, but actually we have at least 3 or even 4. Because we have obviously we have FMC, centralized manager. Right? That's the number one, the main thing. But we also have something called FDM, Firepower Device Manager. Okay, the Firepower Device Manager is a local manager. So you don't need to necessarily have FMC in your network. You can manage FTD device alone with the use of FDM. And this is the web. So you have FTD, it's only on the FTD. Okay, this is a web. So you're connecting with a web browser directly to the FTD, and you can open up the Firepower Device Manager and manage it. Okay, so it's like ASDM was for ASA, but now it's for FTD. This is what you have on 5506. No, because 5506 is this option. It's ASA with firepower on the disk, and the FMC is also on a disk here. A subset, I would say, of FMC features are here. So you are managing with ASDM, and inside the ASDM, you see a little bit of FMC. Right, so that's different on 5506. FDM is only supported on the FTD code, so this combined unified code. And also for small deployments, like if you have maybe some remote branch and you have that local administrator in that branch, you want to give that guy ability to manage this local FTD, then this is a good solution, right? But you need to decide when you are setting up the device for the first time. You need to decide, are you going to manage it locally? Then the FDM gonna be spin-off, or centralized, then the FDM will not be installed, and you need to prepare the device to be managed by FMC. This question, it has separate interfaces for those different modules on the hardware. What does it mean, separate interfaces for those modules on the hardware? Which one? Which hardware you're referring to? 5506, okay. Actually not. There is a one management network, the management interface, the M00 or M11, it's actually on the 5506. And using this one management interface, you are reaching out to the ASA and to the FMC, which is running on the disk. So basically one interface with 2 IP addresses on it. Okay. There is also another manager. That's not all. Sure. Called FXOS. Okay. FXOS. Gosh, what is the FXOS stands for? Not sure. Firepower Extensible Operating System. Oh gosh, extensible. Firepower. So it's actually like this, extensible OS, right? Operating system. This and one more, FCM, which is the Firepower Chassis Manager. Right? Or chassis manager. Yeah, acronyms. Exactly. So if you have, let's say 9300, Firepower 9300, or Firepower 4100, on those two you have the FXOS, because those two guys are like you can combine the, okay, you can think about FXOS like ESX. FXOS it's like ESX in VMware, right? You can run, it runs the whole box, the hardware, the host, okay, and allows you to run different virtual machines. So you can run ASA, you can run FTD, you can even run a third party like Radware. This is called the VDP, Virtual Defense Pro. This is a Radware VDP. It's a third party anti-DOS solution, anti-DOS solution. Right, so those platforms allows you to run multiple softwares at the same time, and then you can do the clustering. For example, if you have multiple FTDs running, you can cluster them all together. On the 9300, it's even more possible because 9300 is consists from 3 security modules, so it's like a blade server with 3 blades in it, and you can run virtual machines on those blades. Okay, so FXOS is basically the underneath the hypervisor, kind of. It manages the hardware and gives the hardware to the virtual machine, like interfaces and stuff. Okay, and FCM is the chassis manager. It's a manager for FXOS. FCM is the manager, a GUI for FXOS. You can manage the hardware with a GUI. Yeah, it's a messy, lot of things. So they the original idea basic idea was to have only one manager. But now we have a centralized manager, we have local manager, FXOS and FCM if we have that hardware. And so depending on the hardware, you have different managers. FCM is having limited functional. FCM is just to manage the FXOS. So it's managing only the, it's a GUI to manage the hypervisor. It's like kind of like vSphere or vCenter, kind of, you can think about it. ESX is a VMware ESX. VMware virtualized hypervisor. ESX, what is that for really? I'm not sure. Right. So it's like VMware ESX. I just, comparing this to the VMware. So the FXOS, it's like a hypervisor, and on top of the hypervisor, you have VMs, right? So FCM is the GUI to that hypervisor. It's like vSphere or vCenter in a VMware kind of thing, right? The FDM, right, the local manager, if you compare it to the FMC, this is limited, okay? Because the local manager will not allow you to manage everything that the central manager allows you to do. Okay, so you need to know about that. I'm going to show you this. Actually, both. We will be using FMC throughout the whole course, but FDM, I will run it for one time to show you how it looks like. Cool, guys. Mind blowing. Let's take a quick break, okay? Grab a coffee and think through all those acronyms for a second. Okay. Then we'll be continuing on that stuff. So let's take 15, grab a good coffee, and be ready for more acronyms after a break. Okay, see you there in 15. Okay, let's move on. So next thing I want to talk about is the deployment, how we can deploy the firepower in our network. You can basically deploy it in two modes, as a IDS or as an IPS. So I will be focusing from now on only on ASA with firepower or FTD. Okay, so on those two, I will not be talking about the 7,000, 8,000 series. So IDS, D for detection, means this is the passive mode. We are not going to take any action on the traffic that we see. So even if there is an attack, we'll just create an alert, but will not block that attack. And there are two flavors of this approach, of this deployment, depending on the hardware you have. If you have ASA with firepower, in routed mode, right? Then you have ASA firepower on a disk. Interfaces are configured from the ASA's perspective, from ASA. And with MPF configuration, you can redirect that traffic to the firepower, and then after positive inspection, the firepower will send it out. Right? But in this case, we don't want to redirect the packet, because if we redirect the packet, this is gonna be the inline mode. We would like to take this packet and send a copy of that packet, right? And packet will be leaving the ASA, and we will be working on a copy of the packet only. So even if there is an attack, the firepower will not do anything about it. Will basically just generate alert. So MPF configuration is on ASA needed to send a copy of that packet. How it can look like: policy map, even in a global policy, I will reuse the default global policy. And for a class, at the beginning of the policy map, each policy map actually, there is something called a class default, which is kind of catch-all class. Every packet is being classified to it. It's like having match any in a class map. As an action, we do SFR. Remember this action? Instead of inspect or set connection, we have SFR, fail dash open or fail or close, depending on how we want the SFR to behave. If we say fail open, which means that if firepower is down, the packets will be still going through. If the firepower is down and we have a fail close, then the traffic is stopped because the firepower is down and cannot inspect that. And to send a copy of the packet, not to redirect the packet, we need to add an option here, monitor dash only. Okay, this option creates a copy of a packet and send it to the firepower for inspection. That's the one of the options if we have a routed mode. If we have ASA with firepower, but in a transparent mode, right, transparent firewall, and this is only for transparent, then we can make additional config. Right, we can use one of those interfaces on the ASA to start listening in a promiscuous mode, and from a networking device like a switch, we can copy the packets with a span. Right, so this is, let's say, gig 01, and with a span we are sending the packets from that switch. Right, so basically the switch is in the path for the traffic, but the firepower is not, or ASA with firepower is not in the path. So on the switch, we just configuring the span session and send it to the ASA to this interface. Okay, that requires additional configuration on a gig 01. Remember, this is only for transparent, so we need to have a firewall transparent first. And then we go to the interface gig 01, and there is a command traffic forward SFR monitor. Okay, that means this packet will be forwarded to the firepower for inspection. Okay, so class default is just a catch-all class. It's always there on the policy map. Even if it's not there, you don't see it if you do show run, but you can type in class default and it's gonna work. So it's catching all the packets. If you want to apply something to all packets, some feature like here SFR, then it's the easiest way to do that is to use the class default. Okay. There's also an option to do IDS in case you are inline, but I will be talking about that in a second. Okay. So this is when you have ASA with firepower on a disk, not when you are using FTD. But obviously the most popular is the IPS deployment, right? In inline mode, which means your firewall is inline to the traffic. Okay? So with there are two options here. You have ASA with firepower on the disk. Okay? In most cases, because it can be still layer 2 or layer 3. I mean routed or transparent. Okay? Routed or transparent firewall. So I would say 99% of cases, this is going to be the routed of cases, right? Routed is the main thing. So even though if you start thinking about it, how it was in the past, even if you talk to the guys that came from SourceFire, they still thinking about their product as the IPS, as this is the IPS, and it's a layer 2. If you probably when you read some books about IPSs, they always say that IPS is the bump in the wire. It's a layer 2 deployment. It's invisible in the network, stuff like that. Okay? Not today, because IPS is just a feature on that device that is a layer 3 gateway or layer 3 device. So in our case, ASA with firepower, that's going to be routed mode. So ASA is in layer 3. Right? It has an IP address here, and we have a firepower software running on a disk, ASA software running here, and we are using FMC to manage the firepower, and we're using CLI or ASDM to manage ASA. Okay, that's the case, but it's 99% of cases this is going to be the routed mode, layer 3. How to use the IPS with traffic that does not cross the device. Then the only option is the option that I showed you on the previous whiteboard drawing. Let me show you that real quick. The span option. This is the only way to do. All right, so let me check that real quick. Okay, sharing the previous slide. Okay, this option. So traffic is going normally through that switch, okay? And with a span, you can monitor that traffic. How to block that? There is no way to block that. If you are not in line to the traffic, you will not be able to block. Simple like that. So IDS is just for monitoring rather than monitoring and alerting rather than blocking something. That's why the IDS is not really IDS deployment is not really popular nowadays. Most people go to the IPS deployment like this. Yeah, obviously the sizing of Geek01, obviously yes, in this case. But yeah, potentially you can. Okay, I'm not sure. I might be mistaken. But I'm not sure if that's possible. But if you have, let's say, 9300 or 4100 device, and you put ASA on it, you should be able to do the same still. But you have, 10 gig interfaces. So possible, but not really popular. Okay, what else? So here, in order to send the traffic, yes, transparent is layer 2, right? In order to redirect the traffic to the firepower and then inspect that and go out, you need to create a MPF configuration on the ASA, right? First, policy map, global dash policy, and for a class default, you put SFR fail open or fail close if you want to do that. So without this monitor only, without this additional keyword, the monitor only means that you're gonna be sending a copy of that traffic, of that packet. Okay, without the monitor only, you are redirecting this packet to the firepower for inspection. That actually, this is the one option. I'm a big fan of another approach with not sending all packets like this, because the class default is actually classifying all packets or catching all packets. I am a big fan of using access list here. Access list, let's call it SFR. Then you can deny something. Deny the permit anything else like IP, any. But the big advantage of this is that you can deny. Right? And then go and create a class, your own class map for SFR as well, matching access list, SFR, and then policy map, even for a global policy, underscore, no, global dash policy. Class, no, underscore, class SFR, and you do SFR fail dash open. Why I'm a big fan of the second solution? Because that gives you the ability to deny something, which means some of the packets will not be redirected to the firepower. Okay? You may think about packets like voice, like backups, so big flows. I don't want those big backups to go through the firepower, because that's gonna kill the firepower. Not the kill, but obviously that's gonna, utilize the firepower more than it's needed. And some traffic may not be going to the firepower inspection at all, like voice, for example. If my voice traffic going through the ASA, I want to keep the inspection or limit the inspection to minimum for voice traffic. So it's not affecting the voice. So it's not adding additional delay or latency to the voice traffic. Okay, so this is a pretty cool option to do that this way. Okay, so for those of you who have ASA with firepower still, and there are plenty of customers that are still using this approach, this is the way to go. And also, this is a really nice if you would like to get rid of the firepower, get out of the line, the firepower or of the path. I mean, for troubleshooting, okay? Because maybe you're thinking that the firepower is causing some issues. So easiest way is to go here and do SFR fail open monitor only, or even get rid of this redirection, and the packets will go through the ASA alone without being inspected by the firepower. That's also giving you additional quick, option for troubleshooting. Okay, there's a question, not using monitor. This makes it inline and has the ability to block, right? Or does it have the ability to block even on a copy? No. The first part of the sentence is true. If it's inline, you can block it. If it's copy of the packet, monitor only, then it's a copy of a packet, then there is no option to block. There is only option to alert. Okay? Or, and this is I think the most popular option now if you want to buy a firewall, you buy firepower 2100 or 4100 or even 9300 if you have that money, and you put FTD on it, FTD, right? Then you don't redirect anything. Everything is going through the firepower features, and it's being managed by the FNC only. You don't need to have any special configuration because all the traffic going through the firepower plus the ASA, because the ASA features are also here, right? But you're not redirecting anything. It's going there anyway. Okay, and this is also layer 3. I would say layer 3 is 99% of cases. To be honest, I don't know about any deployment that is layer 2 in that case. Probably there are some, but I don't know. I never met anybody that is using layer 2. Everybody's using layer 3 for that. So it's not true anymore that IPS, typical IPS, is a layer 2 device. Not today. Okay. Let's move on and talk about features that we have. So just a list of features, and we'll be talking about most of them. So I will be focusing on the FTD now. FTD, or next generation firewall, right? FTD or next generation firewall. I will be focusing on that stuff because that's the future-proof thing. So I would divide those features to two two kinds. Or one is NG IPS features, one is NG firewall features. So obviously NG IPS feature is a snort itself, snort engine, and the IPS or IDS type of deployment, right? The question is it IPS or IDS, depends on how you're gonna deploy it, right? Snort is just an engine that will allow you to use signatures to catch a traffic. A signature is just a description of a packet that you would like to match, okay? So if you have an attack and you know that in a packet there is something here, here, and here, there are three places that must have exactly those things inside in order to exploit some vulnerability on a server. Then you're going to create a signature that is describing this packet. This packet must have this in those bytes, this in that byte, and this in those bytes. And if that's true, then you should drop the packet. So snort is basically seeing all packets, investigating every packet, and comparing it with a description of that packet that we are looking for, okay? Which are the snort signatures, or actually we call them snort rules, but anyway, I will be talking about this later. And also a very important thing about next generation IPS, it's actually the feature that makes this IPS the next generation, is the firepower recommendations. Remember the network discovery? The feature that allows us to passively scan the traffic and build the host profile. Then based on those that information that we gathered about the host, we can map the vulnerabilities to that host, and then using those vulnerabilities we can tune up our IPS, tune up our signatures to tell us what signatures should be disabled or can be disabled, what signatures should be enabled in our environment based on our vulnerabilities. So this is exactly what the firepower recommendations is. Recommendations, because yeah, that's plural. It's just a one click, one button, you click it, and system will generate recommendations for you, telling those are the signatures that based on your current vulnerabilities that we see in the network you should enable. Those are the signatures that you can disable because we don't see vulnerabilities for them, and they can just produce some false positives if they are enabled. Okay. Ronaldo is asking, the signature is based on layer 3 till layer 7. Yes, exactly. You can match whatever you want in the signature. Mostly layer 7, the payload, but everything above layer 4 is actually considered as a payload for snort. So we run the question in the chat. So we run all for some time, and the box recognize. Okay. Yeah, generally the approach is to after the initial deployment of a sensor, of a managed device on of the firepower, keep it up and running for 1 week. So it's gonna be a learning, looking into the packets, knowing what's going on, what's on the hosts, creating host profiles, and so on. Okay, and after the week, you are going back, checking coming back, checking what was discovered, how it looks like, if everything is looking fine, then you can make those recommendations to tune up your IPS policy. It's not possible to do that in one day. That's impossible. If we have outdated system, okay, how we can get refresh. Obviously, there are some situations that we cannot simply refresh, but yeah, the problem is with those systems might be that they are really old, and sometimes even though signatures are still there, they are not enabled by default. But with a firepower, if firepower sees that system and understands what's there, create vulnerabilities for that system and recommend you to enable signatures related to that system. So even if it's old, if it's actually very beneficial, because normally if you take approach, if you don't have that firepower recommendations with the feature in the IPS, how you can tune up the IPS? You do that manually. You take a look at what hosts do I have in that network. Oh, okay, here are some Windowses. So there are no Linuxes in that network. So I should probably disable all signatures related to other operating systems than Windows, right? And this is the way you are tuning that manually. But here you don't need that. Your tuning is based on the vulnerabilities, even for older systems. So that's not a problem, I would say, not an issue. Okay, and the NG firewall features. Okay, starting from a basic thing like we have access control rules. This is actually called access control policy, right? Those are layer 3, layer 4 typical firewall rules. Okay, but also we can do a network discovery that must be tuned up in order to work well. We will be doing this. We can use application detectors, okay, to build a layer 7 firewall rules. Right? So I can use a layer 7 application information in my rule, like HTTP traffic. It doesn't really matter what the port is. Is it HTTP? Right? Then pass it, for example. What else? File type detection. So the system can detect the file types. Okay? So we know that this is mp3. This is an Office file, like maybe a Word file or something like that. And we can create a policy based on file types, saying I don't want anybody in my network to upload Office files or send them out to the internet, right? So this is based on the file magic. It's not based on the extension. That doesn't make any sense to make such thing based on extension of the file. It's based on the file magic. So something that is inside the file header. Okay. Even if you change the file name, it's gonna be automatically detected that this is the correct file type, and you can block it if you want. Okay. This is also very important feature for fire amp. Okay, if you have fire amp, then first you need to detect if the file is executable. Okay, maybe that's the Microsoft executable file or some binary file on Linux or Java jar file, which is also an executable file. We need to detect the file type, and then you can say, instead of just block the file based on an extension, block the file based on the disposition from the cloud. So if the disposition is malware, then you are blocking this file. Okay? So it's not just the blocking based on the extension or file type, is blocking based on the disposition from the AMP cloud. Okay, obviously we have SSL decryption, because most, I think it's more than 60 or 70% of traffic now that is SSL encrypted. So the SSL decryption is quite important. I will show you the use cases for that, but because this is not always needed. For example, people think that in order to do URL filtering for HTTPS traffic, you need to have this HTTP traffic decrypted first. That's not true. You can do URL filtering for HTTPS without SSL decryption, actually. So it's not always needed, but sometimes it's beneficial to have it implemented. What else? Security intelligence. That's a very important feature. Security intelligence is basically a blacklist or blacklists, because there are different types: IP or URL or even DNS based blacklists. And you can download those blacklists from Cisco. Okay, if it comes to the IP blacklist, you will find public IP addresses which are considered bad, malicious, right? Same for URLs, same for DNS, but obviously DNS works for a DNS traffic. So if someone is asking to resolve that name, and that name is also on our blacklist, we will block it, or we will respond, instead of the DNS server to the client, back to the client. We will be talking in all of these things in a greater details a little bit later. Obviously, URL filtering, I already talked about this. We have features taken from NAT, taken from ASA, like NAT, Network Access Translation. So all we already learned on the ASA about NAT is going to be still valid here in the firepower. VPNs are also ported from ASA, site to site, okay, remote access with any connect. So SSL based or IPv2 based, supported in the system. QoS also feature taken from the ASA, mostly policing. Okay. Routing, right? So you can do unicast routing, like OSPF, actually taken from the ASA as well. So BGP is supported, REAP, even ERGRP, but for example, ERGRP cannot be configured from the GUI, because the GUI is not ready to give you those options to configure ERGRP, even though the code is there. So you can use something called flex config in order to send ASA configuration commands directly to the FTD, and it will take it and start using it. So even though you don't have checkboxes for some features, you can still use flex config to configure something on the FTD. And the multicast routing supported as well, PIM mostly. What else? Virtualization. Comes to the virtualization. In the FTD, we have something called a multi-instance. Remember on 4100, 9300, those boxes who have FXOS underneath, that hypervisor kind of thing, you can run FTD as a virtual machine, right? So if in order to virtualize, it's not the virtualization like on the ASA, like it was on the ASA. You are dividing your physical ASA to multiple virtual ASAs. No, here, if you want to have a virtual or multiple instances of the FTD, you're just spinning off another virtual FTD. Let's call it this way. So it's called the multi-instance. So there is no virtualization as we know from the ASA. We are not dividing anything to virtualize contexts. We don't have contexts anymore here. We're having multi-instances. Call it virtual context. Okay, but also failover is supported. Right, we can still do active standby failover. We cannot do active, by the way, but we can do clustering. Okay, but in order to know exact numbers, you need to go to the data sheet and see what platform is supporting what. Okay. Okay, there's a question in chat. 9300 not a ready-made replacement for 5585 yet. That depends on the features that you are using on 5585. But if you are thinking about virtualization and clustering, it's supported now, so you can do that. I would say 98% active failover not supported. But if you migrate to clustering, you don't need to have that anymore. Active failover, right? So I would rather go this way. Yeah, I would say it's now 99% ready to replace 5585. It's almost there. Almost the feature parity across those platforms. Okay, if it comes to the licensing, let me put that here. FireAmp requires malware license. Quite a nice name, right? Malware license. Okay, a URL filtering requires license, URL license. Okay, all other features are requiring either base or threat license. Okay, I must say it's really hard to see anybody without those two licenses, with just the base license, for example. Threat license is associated with everything that requires subscriptions, like downloading something like IPS, for example. IPS requires updating of the signatures, so thread license is needed. Okay, so things like that. So most likely, I would say 99% again, most people are using having those two licenses anyway, plus optionally malware or URL. Okay, things like SSL, VPNs, everything that was ported as a feature from the ASA code is not being separately licensed. So that's good, right? You don't need to have any other license for that. Oh, and one more thing came to my mind. There is also a geolocation. So I would put that here. Right? So geolocation is the feature that you can utilize the geolocation database, a database of information where or from what country the particular IP address is coming from. Okay? So you can utilize that, use that info to create access control policy rules. Yeah, for example, if you would like to block somebody from not your country, outside of your country, or from some considered bad countries, things like that. A very good, very nice question in the chat. Is there a WAF features? No, this is not WAF, right? WAF is a web application firewall. So WAF is being used to catch attacks in a web traffic, like SQL injection, for example. So you can still catch some of these with signatures of the IPS, but I wouldn't consider it as a WAF feature. Okay, so there are some IPS signatures that can help you here, but this is way, away from a advanced WAF. I think the most common and most advanced WAF nowadays is the Imperva one. So Cisco is not developing any. No, Ironport is not a WAF as well. No, Ironport is the proxy. Either it can work as a reverse proxy, but again, it's not a WAF, and there are no WAF features typical. If you want my recommendation, go to Imperva for that. Okay, so now we know what are the features that we can expect from that product. Now we can take a look at where we can deploy it and what features should be used, because we don't need to have all features enabled usually, depending on the place where we deploy. Let's talk about deployment places. Is URL filtering replace WSA? No, at all. I was saying about this, so no, that's a really, really bad idea. Because URL filtering, if you compare it to the WSA, it's on the WSA, it's maybe like one of maybe 10% of features of the WSA, or even less. So no, WSA is way more advanced. Right. So deployment places. The most common, I would say, is the internet edge. A lot of people using this for on the internet edge, but okay, we need to divide that to two different things, for users and for e-commerce. Okay, so for users, we have FTD on the internet edge when we are looking to protect those guys here. Okay? So this traffic to the internet. So in this case, this is gonna be the inline mode. I would say 100% IPS. Okay, nobody is using IDS in this environment, internet edge. It must be inline because it must be able to block something inline straight away. It's layer 3. The security intelligence is the main feature here. Okay, security intelligence. Remember, those are the blacklists. Okay, so if you have malware here, and this malware tries to go out to reach out to the CNC, command and control server, this is gonna be blocked by the security intelligence in many cases. Also, in that case, AMP as a feature is a nice add-on, because if you are downloading a file or if you are downloading a malware from the internet, it can catch the malware here and you don't have that infection. Okay. Now, optionally, I would say SSL decryption here. As I said, SSL decryption is not needed to do the URL filtering based on HTTPS or for HTTPS. But SSL decryption is really nice to have in order to, if this malware, for example, trying to reach out to some server over SSL. As security intelligence still can block the traffic because that's based on IP and IP is not encrypted. But if it's trying to reach out to the server and download maybe some additional payloads from the internet over HTTPS, then SSL decryption is helpful to catch that. Okay. Also the IPS, so signatures for users. I would say this is something that should be there, but doesn't necessarily must be. And same for URL filtering. And this is because if you have a proxy in the network, you don't have the URL filtering here. I would rather use URL filtering together with SSL decryption to create a nicely working SSL decryption policy, so that you are decrypting only the traffic that is going to the particular URL filtering categories. Okay, for example, I don't know, file, sharing, services, storage, uncategorized categories, things like that. Okay, there's a question: how do you set up your policies for SSL decryption? We will be talking about this. I will be doing this in the lab. Yeah. Okay, I'm considering the performance impact, and I will be talking about that. Yeah. Yes. Yeah. So be patient. Okay. And the second, this is the internet Ethernet edge, but for e-commerce. Right? I would divide that too. So in this case, you have FTD, but your clients are on the internet and reaching out to your DMZ-based hosts. Right? So that's a different thing. In this case, inline mode is the IPS mode is the must. Also layer 3. Security intelligence must be here as well because the IP blacklist, okay, IP blacklist. Okay, if there's an IP on the blacklist, it doesn't really matter if this IP is the source or destination. If it's in the packet, the packet will be dropped. Okay, so here, in this case, we are looking for a destination mostly. If this client is not reaching out to the bad destination, well, that's why the security intelligence for. In this case, we are looking mostly for a source. So if someone from the bad IP address is reaching out to our servers, right? Geolocation here is a nice option to have because now we can configure a rule on a firewall saying nobody from China, for example, cannot reach out to my servers. And that's it, right? I don't want anybody from China to connect. And that will help you a lot. If you don't consider thing like that, if you don't have any clients that are outside of US, for example, right? You have a company, you work for a company that is just offering its services to the local market. Then you don't have outside of the US clients. Then you could possibly create a rule saying everybody outside US cannot reach out to my DMZ servers. You know how this is gonna help you increase your security? A lot. You will not see any, IPS events, any tries of, exploit a vulnerability on your servers, any attacks, anything like that, because everything will be blocked straight away based on the source IP address not belonging to the US. Obviously, that's not for everybody, but as I said, if you have a local market only clients, then why not? Or you can just open to the big countries, maybe more trusted countries like Germany, France, UK, Poland, I hope, and other things, and block the others, right? So thing to consider. IPS here is a crucial thing, right? You must have IPS correctly tuned. I mean, this IPS should have all signatures related to those servers enabled. Okay, and I will show you how to do that later in this class. And possibly, okay, SSL decryption. I say possibly because there is one problem with the FTD and SSL decryption. There is no SSL offload possible. Okay, which means you can't behave like a typical load balancer when the SSL is terminated on that load balancer, and then from the load balancer to the server, there is a clear text packet. So you're offloading the SSL from the server. There's no way to do that. Here, it's a little bit different. You have the internet, you have FTD, and you have a server. then you can do this. This is the HTTPS. You are decrypting. Here, decrypting. You are checking that content, sending this content through IPS and all that stuff. And when the packet is leaving the device, it's being re-encrypted. Okay, so this way, this is possible. Right? But if you have situation like this, I would say this is the better way of deployment. If you have a load balancer like that, you have HTTPS here. The load balancer is doing offload, right? Then HTTP is going here, the clear text HTTP without without the SSL. FTD is doing, its stuff. Doesn't need to do SSL decryption anymore, right? Then the packet goes to the server, right? Yeah, in this case, right, when we want to decrypt, then the private key must be on the FTD, right? So usually this is exactly the same thing like on the load balancer. If you have load balancer, you need to copy or move the RSA keys plus the certificate of the server to the load balancer. So same here on the FTD. We'll be talking about SSL decryption. Is there a way to protect these keys? What does it mean protect these keys? You cannot export those keys. Once you import them, you cannot export. That's usually the only protection you have. Admin can see data in clear, but not for the private key. Just the public key can be seen, right? Unless you, or you're talking about the process of, moving this to the FTD. So this way, obviously, the admin will see this in the clear text because it must be imported. But otherwise, the private key is not visible. What about logging? What about logging? What do you mean? Because I'm not getting this question. What about logging? Is it can we capture data in clear? Yes, we can. Yes. Yeah. But the thing is that, and this is why FTD is not supporting SSL offload, because if you as a security device want to be certified to the standards like FIPS, for example, there is a requirement. So when you are decrypting, you are not sending the clear packet out. Okay, so you can decrypt, you can do what you want with the clear packet, but the clear packet never leaves the device. It must be re-encrypted. And that's why, as a security device, the FTD is not supporting and will never be supporting SSL offload. Right. Okay. So those are the Internet Edge deployments. And number 3, I would say data center. That's very common as well, right? We have FTDs, usually more than one, running, protecting our data center. So we have them here connected to the rest of the network. And this is so-called an north-south, right, type of traffic, north-south. So the traffic between user and the data center resources. So in this case, obviously most people go into IPS mode, okay, or IDS. If you don't want to be, for any reason, you don't want to be a bottleneck, or you don't want to drop packets that are related to the critical application, then sometimes people decide to go into the IDS mode. But I would say this is not really a good approach. If you have IPS, you have that ability. If you have it correctly tuned, then you can still be using the IPS mode. An option for you is also something called drop when inline. I will be showing you this later in this course. This is a checkbox, okay, when you are configuring IPS policy. So if you uncheck it, then even though you are inline to the traffic, you are not dropping this traffic. By default, this option is checked, okay? But you can uncheck it, and then even if you're behaving like IPS, you are alerting, generating alerts, events, doing all that stuff, but not dropping. And that's a really cool option for the first deployment, for the first days or even weeks of deployment. So I will be showing you this during the IPS lecture. Okay, with a data center like this, you usually don't use malware, anti-malware. You don't use security intelligence, because notice the security intelligence, the blacklist is based on the public IP addresses. So if this data center is not exposed to the public, then maybe the security intelligence is not needed, okay? Right? So optionally, because you may think, okay, what if this server in a data center got infected with the malware? Then it's going out to the public IP address, which is the command and control server on the internet for that malware. And in that case, yes, I agree. And in that case, the security intelligence might be a feature enabled here. AMP. AMP here is not really okay. Again, it depends, right? If you are worried that this host can be malware infected from the internet, then might be the AMP beneficial here. Previous setup. Okay. Yeah. So in the internet edge, AMP is important, but okay, internet edge for e-commerce. It depends on the policy on the firewall, right? Because traffic from internet to DMZ, highly unlikely that this is gonna be a file. but it might be some payload that is malware payload. Okay, if you have it, then you can enable, but I wouldn't consider this malware in that case, you know, a core feature, right? It's basically, you need to take a look at this, you know, from a real life perspective, right? If you have a policy that your servers are not initiating any traffic to the internet, but just internet originating traffic to those web servers, is there any file that will be going this way or any payload that will be going this way that can be considered malware? I don't think so. Right? So it's more for a user to the internet rather than internet to the DMC. This is what I think about that. Okay, guys. So let's take another quick break, maybe, and after that break, there's gonna be the most important slide for today. Okay, I will be talking about firepower traffic flow. So how the packet is going through the firepower, what are the individual features, and how it works. It's very important to understand that. So yeah, grab a cup of coffee, strong coffee, and we'll be continuing after a quick break. Let's take 15, rest a bit. Okay, see you there in 15, guys. Okay, guys, let's continue. So now let's take a look at the traffic flow through the firepower. Okay, so that's going to be the packet, the flow where the packet is coming to the firepower software, which is, for example, the place when ASA redirects the packet to the firepower, for example, okay, or where the firepower threat defense, the FTD, is starting the snort process. I will be after that. First we need to discuss how the packet is going to the firepower itself, and then I will combine two traffic flows together, the ASA with firepower. Actually, the FTD, the packet flow, gonna be the part of ASA, part of the firepower. So I will combine those two together to show you how FTD packet flow looks like. Okay, so the packet is coming to the firepower, and first it needs to be decoded. So decoder is basically a process that is same implies decoding the packet, checking the CRC, the checksum, checking the OSI layers, right, to get to know how the packet looks like. Optionally, can check the .1q tagging if the packet directly reach the firepower device, like maybe the alt appliances, right, things like that. So basic stuff. Then the real thing happening here, the preprocessors. The preprocessors are some processes that are checking different things in the packet to be able to normalize the packet in order to be inspected further by the snort itself. So, for example, there are a couple of preprocessors, maybe never counted them, but probably something between 20 and 30 preprocessors. There are some preprocessors that are required, like must have, like for example, IP defragmentation. This is the preprocessor to defragment the packets. I will be talking about the preprocessors later in this class, and you'll see why the defragmentation is so important. A TCP stream reassembly, preprocessor to reassemble the TCP payload. Some preprocessors responsible for layer 7 protocols like HTTP, inspect. Right, so you can consider the preprocessors like inspections on the ASA plus normalization that you have on ASA, either on the ingress interface or TCP normalization later in the process. Okay? We will be talking about preprocessors later during this class, not today, next week, likely. Then the security intelligence. Right, security intelligence, call it SI for short. And here we have a security intelligence in this case of IP blacklist. Okay. Then the optionally SSL decryption. Actually, the security intelligence is also an optional thing because it depends on the configuration. If you configure as security intelligence, then it's going to be used. If you doesn't. Okay, then the security intelligence again. Okay, but this time the URL and DNS blacklist, because those things can be encrypted. So that's why they are coming after the decryption, optional. Okay, and then the packet goes to something called an access control policy. Access control policy, or I call it ACP or AC policy. Okay. So access control policy, for most of you, including me at the beginning, looks exactly like typical firewall rules. So we have a rule. Let me put that. Oh, no, or is not that visible. Rule. Then we have a condition for that rule to match the traffic. Then we have an action. Then we have inspection and logging. Oh, those things are important. So let's add a couple of rules here. For example, I'm going to create a rule for SSH. I'll give it a name. Condition will be maybe 10.10.30 network to any on port 22, right? I want to block it. I want to block SSH from this network to any other network. And since I'm blocking, I will not be doing any other inspection for that traffic. Okay? I will talk about logging later. So let's leave it empty now. Another rule for web. So 10.10.10//24, okay, to any on port 80, that's going to be allowed. sorry, allow. There's an action allow. Okay, now I'm allowing the traffic, and I can select what to do with this traffic once being allowed. And in this case, I can choose to send this traffic through the IPS policy number 1, example, IPS 1. Okay, this IPS policy, we call it intrusion policy, is something configured outside of the access control policy. It's a separated policy. So let's say I have IPS1 policy. The policy is basically a set of signatures enabled. Right? I can have multiple IPS policies on a device. Okay, some policy can have some signatures enabled. Another policy can have completely different signatures enabled. Okay, so I just configured that policy somewhere outside of the access control policy, but then I can use it to apply it to a rule as a further inspection. Right, so once the packet is allowed, because it hits the rule action is allowed, it's going to be allowed plus sent to the further inspection by the IPS policy, by the snort. Okay. Another rule, let's say FTP. That's going to be maybe 10.2.2.5, just something. Any on port 21, allow. Okay, this time FTP traffic. First off, I would like to send it to the IPS for inspection, but maybe to a different IPS. I mean, to a different IPS policy. Make it a little bit smaller, IPS. But also, since the FTP is transferring files, I would like to implement anti-malware on those files. I would like to check if those files are carrying some malware or not. So I can apply a file policy also here. Okay, as another further inspection or a next step for that packet. Okay, so there is another policy out there called malware and file policy. Malware and file policy. And this policy I can create with a set of rules again. For example, that's why it's called malware and file, because the purpose of that policy is to do two things: to do file detection, file type detection, and anti-malware. So for example, my policy can be something like this: Office files, upload, block. Right? mp3 files, download, block. So those two rules are just using file detection functionality. They are not using AMP because we are not checking if the file is malware or not. But I can create another rule for executable files. Select any direction, so upload or download, and then do AMP as the action. Actually, the actual action is not AMP, it's block malware. But anyway, just for simplicity's sake. So that's gonna consider or ask the AMP cloud. Okay, so if I see the packet, FTP packet, FTP file being transferred, I want this file checked first. If this is a executable file? If yes, then I will ask AMP Cloud if this file is malicious or not. If it's malicious, I'm gonna drop it. Okay, so malware and file policy is something separately configured and can be applied here to a rule. Same for that policy. Oh, okay, and we have a default action. So, and default. Default action. So typically, default action on a firewall is to block everything else. We are just allowing something and blocking everything else. There is a valid action here, block all. Okay, but there are more than this here. We can, instead of that, of blocking, we can trust all, which means we are passing everything else which is not hitting any of those above rules and just sending it out without any additional inspection. Or we can say, you know what, you can pass it, but do the network discovery on it, which means learn about that traffic. Because trust all is passing, but it's not learning. Okay, network discovery is learning. Or intrusion policy. So send it to the IPS. Let's see. Okay, so the default action can be to send everything else to the IPS. Okay. Right. Now, after that, the packet is out. So those are the individual components of the firepower system. Now, my question is to you guys. Let's say I have another role here for Facebook. Let's call it FB. That's gonna be for anybody going to Facebook, like an application. So app gonna be Facebook. And I'm gonna allow it. My question is, which role in this particular configuration, which role will be hit by the first packet going to the Facebook? First packet going to the Facebook. Not web. And this is because Facebook is using 443, right, by default, straight away. So there is no redirection. Yeah, exactly. The default rule, default action will be used. Because first packet to Facebook is a TCP SYN packet to some IP address, to some server on the internet. And we don't know if that's Facebook or something else. There must be a couple of packets, go through in order to understand what is the application really. Right? So the default action should be. So if you choose the default action block all and you have that configuration with a Facebook, you know what? The Facebook will be working. And that's the auto magic, I would say, because it's working, because this system will automatically pass a couple of packets and until the Facebook application or the application is detected. Once it's detected, the other packets, the rest of the packets will hit the correct rule. Okay, I'm just saying how it works because you may be, if you're gonna be installing the latest software, you will not notice that. But I was installing software like from 5.3 above to 6.5 now, and there was a different behavior. For example, in 5.3, if you had a default action block all, this Facebook rule will not work because this is what exactly happened. The first packet will hit the block and it's gonna be blocked. So it should work. It should work this way. But a good thing is, even though this system will automatically send some packets through, those packets will go through the IPS anyway. Okay, so it's not like a couple of packets will be not inspected at all. No, they will go through the intrusion policy. Same situation is with URL filtering. Right? Let's say we have any to URL shopping. Allow, right? And I want this traffic to go through IPS number 2 or policy number 2. Now, we don't see the URL in the first packet, right? We need to have at least 4 packets to see the destination. Okay. Obviously, if there is a SSL, there can be more than 4, but depends. Okay. This is gonna be working even if you have default action to set to block all. But I just wanted to show you how that you need to be how to say that, aware of such behavior. For example, Palo Alto is using the same approach because everybody is using the same approach. The problem is with Palo is that people are not even aware of such thing, and it works automatically, and people say, "Oh, Palo is good because it's working on Palo by default." Okay, we can make it working by default, but then how you can trust that system if it's doing something completely not right. And so you need to be aware of such things. Obviously, everything here is considered, it's done top down first match, right? So like typical firewall, but there is more than this. It's not just a firewall. Notice that it's a firewall plus it's sending the packet to the next inspections, like IPS or file. Someone was asking about where the NAT is. That's going to be a little bit later, okay? If we don't assign anything here as an inspection here, then the packet will be allowed and sent out without any additional inspection. Okay, so it's not like every packet in this system is going through the IPS. We need to tell the system which packets should go to the IPS, which packet should go to the file policy. Okay, so now everything here is actually the whole access control policy is applied to a device as a configuration, okay? Because that's the device's configuration, that's the policy on the device. So we send it during a deploy process. We are sending that to the device. Actually, almost everything that we configure on as a policy must be first applied somewhere in the access control policy in order to be applied to the device, including the security intelligence. Right? When you're configuring the security intelligence, you're configuring it here. There is a tab on top of that called security intelligence. Security. Right? There is a tab here. There's also a tab called advanced, where, for example, the secure SSL decryption is applied. But this is applied here. Security intelligence here and security intelligence here is applied on the security intelligence tab. There's a question, is there a way to view the configs that are being pushed to the FTD before a deploy like the Palace? No. The only way is to see that there is something changed. You don't see what exactly was changed. Yeah. Where NAT is done will be on the next slide. Okay. How to distinguish between SSH and SFTP based on the port in this case, or based on application detector. Not necessarily, doesn't need to be the same. Okay, but application detector can be used. Okay, my question to you guys, there are two questions. One question is, based on what you see here on my beautiful drawing, how do you think, how many intrusion policies can be applied to a single device at the same time? How many intrusion policies, IPS policies, can be applied to a single device at the same time? That answer is one. Not a good answer, because on this screen I see two. Jeremy, nice answer. As many as rules, yeah, exactly. As many as you want, really. Many IPS policies can be applied to a device at the same time. Okay, obviously nobody does it per rule, right? If I have 10,000 rules, I'm gonna have 10,000 intrusion policies. No, rather I have maybe 1, 2, 3, 5 policies, and I use them to different roles to be applied to different roles. How to guess or how many intrusion policies to use? We will be talking about this during the lecture of intrusion policy. So you'll see, I will show you an example how to decide about how many intrusion policies should I have. Oh yeah, Ed. Yeah, that's actually my second question. How many access control policies can be applied to a device at the same time? Right. That was my second question, and already answered by Ed. One. Right. This obviously I can have multiple access control policies on the FMC because everything is configured on the manager, but I can only apply one of them to the device because this is the device's configuration. Is the intrusion policy in default action same as intrusion policy in inspection? Can be, because when you select the intrusion policy here as an option for default action, you need to select one of the intrusion policies that you have. So it might be the same, and it's usually the same. This is very important slide. I will keep it. I will be referencing to it. But now, that was the firepower, right? So if you have, let's say, for example, ASA with firepower, okay, and the packet coming, and MPF is sending the packet to firepower, the process that I just described is happening here. Trust, I just put the trust on a default action. Yeah, but I will be talking about individual actions later. Okay, so that was the process here. Okay, so now I'm going to show you the whole process for FTD. Because remember, FTD is the ASA with firepower in the one code. So the packet coming here is already on the FTD. So now let's take a look at the FTD's traffic flow. FTD, so ASA plus firepower in one code, traffic flow, packet flow. Traffic. Okay, combined. So packet coming to the FTD. Okay, doesn't really matter if the FTD is, or the software, FTD software, is installed on ASA hardware or on a new platforms like FP4100 or FP2100. Right? So packet coming to the ingress interface first. Remember, the ingress interface from the ASA is being checked, IP normalization, checksum, all that stuff. Then someone asked about NAT. Here we have a destination NAT or an NAT, because remember, this is the feature, the NAT feature is taken from the ASA code. Okay, so an NAT or destination NAT is happening first. Then we check the routing. If we have a route to the destination, then we check if we have a connection. Is it the first packet in the session, or maybe this is a packet from, middle packet from the session, right? So if no, right, means this is a new packet, new connection. We are creating this connection, and we send that to the pre-filter access list. We'll be talking about this later, probably next week. Then we are checking NAT rule, like on ASA. Remember, ASA was checking the NAT rule, if NAT rule exists, because NAT rule can send the packet or redirect the packet to the different egress interface. Okay? Then we have inspection. Okay, and a part of the inspection is actually send the packet to snort. Okay, and this is exactly what we had on the previous slide. Decoder, then pre-processors, then security intelligence based on IP, then SSL decryption optionally, then security intelligence again based on URL or DNS, then access control policy, and the access control policy per rule, right? The rule can send the packet to IPS or to the file policy, right? Then the packet is out here, going out, and then SNAT, source NAT is done. So we are translating after all that stuff. Then the QoS is done. Then the packet is on the egress interface, right, based on the NAT rule or based on the routing. Once we have that packet on the ingress interface, we need to find out the next hop. So we do layer 3 lookup, perform that lookup, so next hop. And once we have a next hop, we need to do layer 2 adjacency check, basically find out the MAC address for the next hop. And finally, the packet is out on the wire. And notice this thing here. This is what I described on the previous slide. Right? So this thing in blue is taken from the firepower. This is the FP. The rest of that, before and after, is taken from the ASA. But now it's a one code, one flow. Okay? So if you are configuring access control policy on the FMC, you are managing all of that with a FMC now. So if you are configuring the access control policy rule going here, but also going here. We call it pre-filter rules plus access control policy rules. I will be talking about this in more details later. I don't want to kill you by too many information here. Okay, so that's the whole traffic flow from the beginning to the end through the FTD. So see, some of the features are taken from the ASA, then the packet is going through the snort and all the snort related, firepower related features. Then the packet is going again through some rest of the features from the ASA, like source NAT. Okay, by the manager, but the manager of all of these things now is the FMC. Okay, I will be referencing all that stuff later because that's very important to understand what's going on. Okay, let's take a look maybe to the lab. So first off, let me show you how to deploy the FTD. If you have it, maybe ng firewall virtual initial setup. I will be doing this in the lab in a second. Okay, so. But first off, if you have that, you basically go to the. Wait a minute, where is my? Firefox. Here. You go to the download the software Cisco.com. You look up for ng firewall virtual. See, this is the firepower threat defense software. So ASA plus firepower. The latest release is 6.5, so you go to the 6.5 and download it. For your specific, server. In my case, I have this package, the VMware install package for ESX 6065 or 67. This is tar.gz. Basically, you need to download this file and untar it or ungzip it, unpack it. And then there gonna be the OVA file inside, so you can deploy it with a vSphere or vCenter you have. So basically, this is the step one: deploy ng firewall virtual OVA, right, image on ESX, right, VMware. And basically, there are gonna be two OVAs in that archive. One gonna be ESX SX in a file name. Another gonna be VI in a file name. ESX, you can use vSphere to deploy. Okay, for VI, you need to have vCenter to deploy, because VI is using some additional configuration. Right, once you have it deployed, I have it in the lab already, deployed like this. You need to log in to the console of that device. Okay. In our case, that's gonna be you're gonna have access to that device through the lab portal, and the default credentials are admin, and the password is admin123 with a capital A. That's a default credential, always like this. 3, once you log in as admin, there's gonna be a setup script gonna pop up or automatically will trigger, where you can configure when you need to configure things like management IP for a device, password, gateway. You need to accept the EULA, right, the agreement for license. You need to specify the firewall mode, right? Is it a routed or transparent? Management mode for local or FMC or central, right? So local or central. Local is FDM, the central is FMC. Okay. Once you have that done, Number 4 gonna be to prepare your FTD device for registration. So you need to tell the FTD you're here at this prompt that FMC can manage it. It's a command configure manager add. Okay, you specify FMC's IP and you specify a key, which is going to be a one-time password. So FMC will be coming from that IP address, will authenticating with that key, and then it will be able to register the FTD, the managed device. Okay. So once this is done, number 5 is to go to the FMC and register. Right. So the FMC is basically registering FTD. This registration is about creating kind of SSH tunnel for management. And over that tunnel, the whole communication is done, including the events, including the configuration changes, heartbeats, stuff like that. Okay, let me go to the lab and start doing this. Oh gosh, I cannot log in. Finally. Okay, I'm gonna use the VNC to connect to the FTD. Notice this is the FTD. Just this is the console connection to the FTD with Firepower Threat Defense or VMware version 6.5. I log in initially as admin 123 with a capital A, and there should be a setup script triggered. And here we go. We first must accept the EULA, so hit enter, read this through. Okay, hit space couple of times. Now consider, talk to your lawyer, and so on. Say yes, and here we go. We need to enter new password. Okay, I'm gonna use 1234 QWER, standard one. IP address, yes, I would like to have it. IPv6, no, thank you. IPv4 via DHCP or manually. Notice that in the brackets you have the default answer. So if you hit enter, that's going to be taken. So you don't need to type manual here. Right? Okay, what is the IPv4 address for management? In my case, that's going to be 10.10.2.10. That's the management network in my lab, 10.10.2, right? What's the net mask? Okay, that's okay, /24. What's the default gateway? 10.10.2.2. FQDN, FTD, demo local. Okay, what is the DNS servers? There are 2 DNS servers already provided, which are the OpenDNS. Might be fine, so it's okay if you have access to the internet. Okay, search domain, not needed. And now very important question here, manage the device locally. And notice the default answer is yes. So if I hit enter, the device will spin off the FDM, the Firepower Device Manager, the local manager, and I will not be able to manage this device from the FMC. And to show you that, I will hit enter. Normally, you should say no to manage the device from the FMC, but I will change that later. That's possible. Okay, let's leave it for a couple of. It finished, but it will not be ready that fast. From my experience, I will not be able to connect to that device yet. Let me check if I can ping it. 10.10 to that 10. Yes, I can ping. 10.10 to that 10. Okay, see. Now it's loading. So this is the local manager, FDM. Okay. Admin, and I don't know, probably this is the correct password. Oh, that was fast. Okay, I'm surprised. Sometimes it takes a while for this server to spin off. Okay, so notice this is the local manager for my device. It's showing some picture of that device, even though this is a virtual device. By default, there are 8 interfaces. I have 2 of them up. Right, 0.1 is the inside network, 0.0 is the outside network to the internet. And here is just a setup wizard. Okay, I can click next, next, finish. Or if I want to configure it manually, I can just skip device setup, click that. Then there is a question, do I want to use to skip? And do I want to use evaluation license? Yes, I do. So for 90 days, you're gonna have all the options, all the features. And that's really nice about that for testing. Click confirm. Notice that device initialization is still in progress, so it will take a while. Okay, since I'm waiting, I will connect to the FMC. This is the FMC's console. Notice Cisco Firepower Management Center for VMware 6.5. Okay, I log in the same way, admin with admin123 default password, and it's gonna trigger the same or similar bootstrap process. Okay, yes, I agree. Okay, new password. And unfortunately, I cannot use 1234 QWER because that's going to be considered too weak. I need to change the password for something more. No, maybe I use build. Okay. Host name or FQDN. That's going to be FMC demo local. IPv4 manual, yes. What is the IP address? 10.10.2.20. Correct mask. Default gateway 10.10.2.2. And this is the DNS. And NTP. Okay, I will leave it as it is. Are these settings correct? Yes. Okay, so now I have my FMC ready to connect to it via the web browser. Okay, let's get back to the Firepower Device Manager. Okay, so notice this is a quite nicely looking. I like that. This GUI, it's quite fast, I must say. So interfaces, if I click or view interfaces, I see the interfaces. Two of them are enabled. One of them even have the IP address. Notice that by default, this device is going to have IP address of 192.168.45.1, which is static. I can obviously click here, edit, to change that configuration. Right? You can use DHCP if you like, or change the IP address. What else? Routing, static routing. Notice that only option possible here is to create static route. So there is no dynamic routing basically possible. Right? So that's the one of limitation of the local manager. No dynamic routing. Those are the updates, licensing. Actually, I need to go here in order to enable additional license, because by default, when I enabled that evaluation period, it just enabled the base license. If I would like to use threat, I need to click here, enable, which will allow me to use IPS. Right? If I want to use malware for file policy, if I want to use URL for URL reputation, I need to enable all of these, and remote access VPNs. Okay. Actually, the licensing is a smart license, which means this is the online license feature. You need to be connected to the internet in order to get the license. Backup and restore, troubleshoot. Notice that site-to-site VPN possible, remote access possible, but I don't have a license enabled. Some advanced config is also possible, including flex config that I can use to add some additional features to it. Okay. For system settings, I can change other things if I want to. Here. Okay, what about policies? So if I go to the policies, and this is the most important thing, I can create, this is my access roles. I can create access roles. Let's call it web, for example, source, okay, any zone, any network, to port, HTTP and HTTPS, destination any, sorry, that's a source port, okay, so I cannot use this, so destination port, not important. Right? Then the applications can be used. Notice that I have the application detectors. Okay, Ed, thanks for a link to the smart licensing. Those are the applications that I can use on Facebook. There are Facebook as an application. Yes, I could possibly add the application Facebook, or URLs if I have that license enabled. Users if I have user authentication. Intrusion policy, what to do with that traffic. I want to send it to IPS, and I have 4 default IPS policies. Okay, those are the names of default policies. Connectivity over security. This is a really weak policy, having only 500 signatures enabled out of out of 35,000, 40,000. Balance security and connectivity, that's the middle one. Security over connectivity is more secure because more important, security is more important for me than connectivity. And the maximum detection, which is kind of experimental policy, I would say, I wouldn't use that one because that's kind of dangerous. It has some rules or signatures enabled that might not be enabled in any other policies. The balanced is the middle one. Okay. File policy can also be applied here if I have it, and logging. Right, so I can log that activity and click OK. So this is what I can configure from here. Notice that NAT is also possible. Security intelligence is also possible. Identity, which is actually the identification of the users. SSL decryption possible. Okay, and intrusion policy possible. Yeah. The problem is that I have access to those 4 default policies, but I don't have option here to create my own policy. So creating a custom intrusion policy is not possible. Doing the network discovery, doing the tuning of IPS, not that possible. How many interfaces on FTDV? 8. Yes, by default 8, but we can extend that. But I think there is a limitation of VMware to 10 interfaces. 10 is the max on VMware, I believe. Throughput limitation on FTD? No, not limited. If you have license, it's not limited at all. Without license, it doesn't work at all. So there's no throughput limitation. Okay, and the basic monitoring, which looks pretty nice. Even it's faster and nicer than I would say the FMC, sorry. But yeah, so the main limitation here on the local manager is no dynamic routing, no custom IPS policies, no network discovery, and no IPS tuning. So that's the main limitation. Right? Once you change the config, you need to deploy. So you click that icon here, and you can deploy. It's showing us what was what's going to be deployed. What else? Tasks, and here we have a CLI. That's a really nice option like that. So you can do show IP. That's gonna send the traffic, send the command to the command line and shows what is the configuration. Right. So that's the basic FDM. I don't want to focus on the FDM because that's not a real, enterprise solution. So if you want to manage that from a centralized manager, I have it already here. That's the 20. Okay, that's the Firepower Management Center. Admin and my password. Yes, mirror. I can put that on this on the notes. Sure. Okay. The first question is about licensing again. Fortunately, here I can click the start 90 days evaluation. By the way, notice here that this option is enabled, enable Cisco Success Network. If you want to send some telemetry to Cisco, you can leave it selected. I would not. So I will save that. Okay, or you can skip and do that later, but I will enable that evaluation now. And notice that I'm on a device management where I can add my device to the manager. Right, so I can click add device, and from here I need to specify IP address of the device, which is in my case 10.10.2.10. Display name, that's going to be FTD. Registration key, that's the one-time password, Cisco123. And I need to specify the access control policy that's going to be pushed to the device. And by default, there are no policies, so I need to create one now. Let's call it my initial, okay, without initial, my ACP. Okay, and what the default action gonna be for access control policy? I will select intrusion prevention, because I know that the default access control policy has no rules, no firewall rules, only the default action. So if I say block all, then this policy will be blocking everybody. But with intrusion prevention, this policy will be opened. I will create that one. Okay, and then this to select the licenses that I would like to apply to the device. Notice the base is always there, but I can apply threat plus malware to use AMP and URL filtering to use URL filtering. This option for transfer packets is an interesting one. It's actually about when the IPS is dropping some packet because of the signature triggered. It's usually the case that the IPS catches that packet and sends this packet capture to the FMC. So the packet capture will be assigned to the intrusion event. And so if you don't want that, you can uncheck this option. I mean, with this option unchecked, the packet captures or captured packets will not be transmitted to the FMC. This is sometimes this is a requirement by law. For example, in Switzerland. In Switzerland, you cannot do such thing like you have FTD, for example, in Germany, but FMC is in Switzerland, or another way around. There's an FTD in Switzerland and a manager in Germany. You can't take a packet from the Switzerland and send it to Germany, okay, by law. So in this case, you can uncheck this option. No, that's before GDPR, way before that. Okay. Oh, okay. When I click register, nothing will happen. Actually, it's gonna time out because I forgot that I have a local manager enabled. So what I need to do, if I do show managers, it's gonna tell me that I'm being managed locally. So I need to do configure network delete. Okay, sorry, configure manager, manager delete to delete the local manager. Yes, I'm sure. It says that I'm gonna lost my license. Notice in the background the FMC is trying to reach out to that device and register, but obviously that device is not ready to be registered yet. I need to first delete that manager and then configure manager to be the FMC. Okay, so configure manager add 1010 to that 20, that's the FMC. Cisco 123 is the one-time password. Okay, now if I do show managers, it's gonna tell me that my manager is 10.10.2.20 and it's pending. The registration is pending. Okay, so I will see. We'll see if that's gonna add my device. Okay, guys, I think because this is gonna take my take up to 10 minutes even. So let's maybe take a break. What about lunch break now? Right, and then we're gonna continue. I will leave it registering, and let's take 30 for lunch break. Okay, we'll be continuing after that. So see you there in 30. Okay, guys, let's continue. And so my device is registered now. I see it on the list. Notice that it's a routed mode, firepower threat defense for VMware 6.5. Okay, and chassis, so obviously there is no chassis, so no information. There are licenses assigned to it, and it's a bug actually, because here we should see the access control policy after initial registration, but when we refresh that page, it's gonna show us the access control policy applied. So I need to refresh, hit refresh button, and we should see that access control policy is really applied to that device. Oh, here we go, my ACP. Okay, so I have my device registered, so now I can start configuring it. I will start with interface configuration, so I need to click this pencil icon next to it to edit. And it's gonna take me to the screen when I can configure interfaces. Notice that I have 8 interfaces, and I will start from gig 00. What is my lab look like? Let me put that info here. Notice that we have ASAs, ASA1 and ASA2 in the following setup. Is the internet. Here I have an inside router, and here is my employee PC. I also have here a DNS, and both devices, ASAs, are connected to the management network. But now I'm going to add FTD, which is also here connected to the same networks. Okay. So far, the default gateway pointing to the ASA1, I will move that default gateway to be pointing to the FTD. So I have the internet access. Okay, and the management is obviously the management network is here. I have my admin PC, and I have my FMC, right, connected to the management network. And ASAs, both ASAs are connected to the management, and also the FTD is connected to the management. Right, this management network is 10.10.2.0. Employee PC is 10.10.9.0/24. The inside network is 10.10.1.0. This outside network is 192.0.2.0. Okay, I already assigned in the previous labs IP addresses to the ASA. So ASA has that 1. This one has that 3. This guy has that 2. This guy has that 2. This is 3. This is 1. Here we go. So for FTD, I'm going to use 10. That 10. That 10 here, that 10 here. Okay. So my outside interface, this is going to be the gig 00 outside. This is going to be gig 01 inside. Okay, configuring name outside. I need to enable this interface. Okay, I need to define the security zone that this interface belongs to. ASA has no zones, but Firepower is using zones, so I need to have out, let's call it out zone. Out zone. Okay, the IPv4 gonna be the static 192.0.2.10/24. And the next one gonna be inside, enabled, and security zone, I'm gonna call it in zone. And IPv4 10.10.1.10/24. Okay, I need to save. When I saved that information only on the FMC. I did not send that to the device yet. So if I take a look at the device real quick, if I do show IP, it's still showing me nothing, no IP addresses. Okay. I will create the routing as well, at least the default route and the routing pointing to the inside network. Make that work. Notice that this is the FMC, so all the dynamic routing is supported except via gRP actually. But I'm going to use static route only. I'm going to create a default route pointing to the internet router. So we need to select the interface, the outside, for any network. So notice this is an object 0.0.0.0 /0 when I use it. And the gateway I can create as an object, or I can just put an IP address of a gateway, 192.0.2.2. That's going to be one route. Another route to the inside network, so to inside interface, to all 10 networks, 10.10.1.2, which is the inside router. Okay, so I just created those two routes. Not using DHCP, not using inline set. Inline set is basically for layer 2 when this is a bridge between two interfaces. And the device tab is just showing me all the information about that device, such as name, mode, right, the system version, licensing information, health of that device, the management, is it up and running, applied policies to that device. That's really cool. This is a quite recent information added to that page. So you can see what are the different policies applied to that device. Inventory details, also something new, was quite recently added. Okay, so now I can click deploy to send that info, to send that configuration to my device. I can. It's always a good practice to click and expand that to see what is going to be sent. In this case, device configuration. I click details. I see the interfaces and the static route. I select the device on the list and click deploy. If you click that icon next to the deploy button, you're going to see the deployment process. You can also see the individual tasks on the tasks tab. By the way, from this place, the device tab, you can also shut down the system or restart the device remotely. This is quite nice option. Okay, it's still being applied. Now I can go to the policies. By the way, I don't know if you guys are aware of that, but in 6.5, the latest system, there is a new look and feel of the FMC. So this is the old theme, let's call it. The problem with that is the menu, is the top menu. Notice if you want to go to the analyzes, for example, connection something, or analyzes, file events, something like that, or host, it's really hard to sometimes to click on what you're looking for. If you move your mouse too far, it's gonna disappear. So it's really cumbersome to use that menu. That's why they decided to add a new theme. If you go to the user preferences, because that's the per user option, you can change the UI theme from the classic to the light, which is still experimental, which means something may not, work, may not be displayed correctly, stuff like that. If you change it, it's gonna be a completely different menu and look. And it's pretty nice. I think it's nicer than the previous one. By the way, here next to it is the time zone. So that's very important if you are looking into logs, because all logs by default are using UTC when they are sent from the device to the manager by using UTC time zone, and the time zone for display is a per user preference, right? So if I'm here under the admin user preferences, I can select my time zone, because by default for every user the time zone is New York. So it might not be the time zone that you are in, so you will not be seeing correct time in the logs. Question: is this UI the old Source Fire Defense Center theme? No, the previous one is the old one. You have that. This option is available in 6.5, which is the latest software. Okay, that was added to 6.5. And now when you click menu, it's like on Cisco ICE, for example. So all options are expanded, and it's much easier to click on them. Right. So this is a really cool thing to have that. Okay, let me go to the policies. So first off, I go to the access control policy. But by the way, my deployment should be finished by now. I can click this notifications icon and I see, okay, that was done. It took almost 2 minutes to do that. Now when I go to the FTD, I can do show IP and see if my IP addresses are here. And see, this is the configuration I sent to the device. Routing should be here as well. If I do show route, I see the default route pointing to the outside router, and I see the 10/8 pointing to the inside router. That's cool. Okay, my access control policy, I can edit that. And this is the policy that I created during the registration, so it's empty. So it has just the default action. And since I choose the default action to be intrusion prevention, I have that as a default action, intrusion prevention. Okay, and no rules in this access control policy. I can obviously add some new rules. There are two categories by default here. Notice the mandatory and the default. To be honest, this is completely irrelevant to anything. The only useful thing about that is that you can collapse or expand all those sections. Okay, so it actually doesn't really matter if you add your rule to the default or to the mandatory, just the label. Okay, so if I click add rule, it's gonna pop up this screen, and I can name my role like web access. I can select the action, allow, trust, monitor. I will be talking about the actions in a second. Okay. Then I can make a condition, so zones, networks, VLAN tags if you have layer 2 deployment, users if you have user identity, applications, ports, URL filtering if you use it, or attributes from ICE. Those are the conditions for the rule. And then you have inspection tab where you can specify the next step. So once the packet is allowed by this rule, it's going to be sent to this intrusion policy that you select here. Okay, so for example, I select connectivity over security. So my traffic hitting this rule will be sent to the IPS and the policy of that name. Optionally, additionally, I can add the file policy too. Question in the chat: by default, all traffic is allowed between interfaces, unlike ASA. Yes, that's true. Actually, there is on FMC or sorry FTD, there is no concept of security levels anymore. Even though that half of the software is ASA, there is no security levels. But if you do show name if, you will still see the security levels. Notice the security levels are set to 0, okay, and they are actually not being implemented here. Okay, so all traffic is allowed between interfaces by default. Obviously, depends on the default action that you have on the policy, because you have only one policy, right? So if you take a look at the device, you have that access control policy here, right? Doesn't really matter if you are routing this way, right? The packet must go through the access control policy. If you're routing this way, packet will be going through the access control policy. If you are routing this way, packet will be going through the access control policy. Okay, so access control policy is a central point. There is a one policy with firewall rules that will tell what to do with the traffic. It doesn't really matter if the traffic going this way or that way. And I don't want to say by default it's allowed, because it depends on the default action on the access control policy. If it's empty and the default action is block, then nothing will be allowed. Okay, so just to be exact. Also, actually, I forgot to tell you about this logging. I wanted to tell you about logging, but I forgot. Let me open up traffic flow that I'm drawing. Okay, this one. This log section, this log option here. You can enable logging per rule. And this is what most people do, actually, because they want to see something in the log. If some traffic hit that rule, then the log will automatically log a connection event. Okay, but my opinion about this logging is this: I don't like it. And because of that logging, people are usually having other problems, like, for example, the FMC is very overwhelmed, or they see some logs, and they can check out the logs maybe 30 of 1 hour ago, and they cannot get back any farther than 1 hour because of that many logs that the FMC is not able to show anything more. And that's a problem, and that's the problem comes from the misunderstanding of this logging feature. because this log here, if you select logging here on the role like this, okay, by default, this log, this is a connection log. This is just an informational log. It has nothing to do with security, right? So it's not a security event, not security related. It's just a connection. Okay, and by default, notice when I select that at the bottom here, it's showing me that event viewer will be the destination for that connection event. The event viewer is basically the FMC itself. Okay, so if you do this, then every traffic, every connection that will hitting this rule will be logged in the connection table, which is quite overwhelming, especially for traffic like HTTP, DNS. Okay, so I highly recommend not to do this. Obviously, in the very beginning, you can do that because you want to see that something is working. But later in the production, you don't need that anymore. Okay? You don't need that because even if it comes to the security, let's say you have a packet, this packet is hitting the web rule, okay, is being allowed, and it's going through the IPS, and one of the signatures in that IPS policy is dropping that packet because there was an attack, then even though you don't have that logging enabled for that role, there's gonna be the IPS event created in the system. So intrusion policy will create intrusion event, and by the way, along with this intrusion event, there's gonna be associated connection event created for that specific connection. Okay, so once you know that, you don't really need this logging feature here. Okay, so if anywhere in the system, if there is a security related event, then this event will automatically create a connection event as well. Okay, so you don't really need that. But someone may say, hey, wait a minute, you know what? I have a situation that I work in that environment that I need to have logging, connection logging enabled all the time, because maybe one day someone comes to me and say, you know what? I need to know who was connecting to this server, a week ago, and I need to tell the guy who was that at least IP address. And so I need to log every connection event. So what can I do in this case? So in this case, I have another option for you, which is way better than logging to the event viewer. Notice you can still log here, uncheck the event viewer, and you can check the syslog server. So when you select this option, then all connection events will be going to the syslog server, and guess what? They will be going directly from the FTD, not from the FMC. So FMC will not be overwhelmed by all those events because they're gonna be automatically sent out from the FTD, from the device, directly to the syslog server that you specify here. And this is a nice option to send only all the connections to the syslog, just for for information, to have that data. Okay. Okay, so let's create that role. Okay, so it was automatically created under the mandatory category, but you can create your own categories if you like. So remember, you have only one flat access control policy, but you may have different kind of use cases in your environment. Let's say this is the FTD, and you have, let's say this is the internet, this is the DMZ, and this is the LAN. So you have two use cases here. One use case is your LAN users going out to the internet. Another use case is the internet coming to your DMZ servers. Right? So in this case, it would be nice to have two categories, like users to internet. Right? You need to insert that into mandatory or above rule or whatever. Like this. And another category, internet to DMZ. Okay, and then since this is the web access for users, you can just move it down to users to the internet. If you are not looking currently for the users to internet rules, you can just collapse that. Okay, so the purpose of the categorization here is just to make admin life easier. Okay, another thing. If I click add rule, I have a different actions, right? Let me talk about those actions. Okay, here we go. We see that. Right. So first off, we see this. This is the allow, which is exactly, it's like a permit on the ASA. Permits the traffic, sends it to further inspection. Right? If obviously if the inspection is selected. Option number 2, we have trust. Trust means bypass. Bypass, no further inspection. And by the way, there is no network discovery too. No network discovery. That's quite important because sometimes you create a trust role to bypass some traffic, and then you notice that you don't have any host profiles for that for IP addresses that hit this role. And this is because the trust is like a bypass and we don't do anything else. We just sending the packet out. Right? Monitor, actually, like that. Okay? But this is in this GUI. It looks like this in this GUI, in this theme, I mean. Monitor. This is for logging, for troubleshooting. Logs, connection, and sends the packet to other rules. Okay, which means that if you have monitor option, then it's just logging the packet. Notice that when I select the monitor, let me go to the logging. If I do allow, I have option to log at the beginning or at the end of the connection or both, right? If I select trust, I can do the same. But if I select monitor, notice that it's automatically grayed out those options, and logging at the end of the connection is selected. So monitor rule is just for troubleshooting. You create it usually at the top of your policy, and just to check if there is some traffic hitting this rule. And this rule does nothing else than just logging, and is passing the traffic further to other rules. So it's normally it's a first top-down first match approach, but here for a monitor action is actually top-down match and then match the other. Okay, so it's not matching the packet really. I mean, it's not stopping the packet. What else will we have here? Two more. Block. Block. That's obvious, right? Deny. Denies the packet or connection. Block with reset, that obvious, right? It's doing the same, but then sending the TCP reset back to the client. And interactive block, that's interesting. Interactive block is like conditional allow. And works only for HTTP. It allows you to send back to the user kind of warning page saying something about policy and so on, and the user must click continue in order to be allowed to go out. Okay, so if you create a rule interactive block, you must actually use the port for HTTP, something like that. Not block, but interactive block, like conditional web access. Right, so interactive block and then add. So what will be the page displayed for a user? It's here under the HTTP responses tab. You have two options here: interactive block response page, which looks like this. This is the HTML, and you can change it. You can create your own if you want to, custom. Notice what's in the text here. You are attempting to access forbidden site. You may continue to the site by clicking the button below. Okay. Also, there is also a block response page that you can use in order to let people know that the website they are trying to reach out is blocked. So when you do the block for HTTP, they're gonna be the block page sent back to the user. Okay. Okay, let's take a look at if that works. I'm gonna save. Okay, if I want to see the events, let me do for a default logging for a default action. So I click this papyrus icon and to log at the beginning of the connection, right? I will the web access for was for everybody, but yeah, let me do that condition so I can move it up. Like this. Save and deploy. Now it's telling me that the access control policy is being sent and the intrusion policy because one role is using intrusion policy. I need to deploy that. Okay, it's saying something about logging. Okay, because I don't have, okay, syslog. That's right. I was configuring the logging here. Yeah, I don't have that syslog server specified. That's the problem. Okay, meantime, I need to change my configuration because my inside router is pointing to the ASA for the internet. So I need to change that. Gonna be 10 to the 2. Yeah, so default gateway now for this inside router is 10.10.11, which is the ASA. I want to get rid of that. So I'm gonna delete the default route. Yeah, I don't have it now. And I'm gonna add a new default route pointing to 10.1.10, which is my FTD. Okay, now I have it. Right, now I can go to the employee PC. Okay, try to ping 10.10.1.10, which is the FTD itself. Oh, I can't ping it. That's strange. Can I ping it from here? 10.10.1.10. Oh, really? 10.10.1.10. Okay, interface is up. Okay, I cannot ping something. Anything inside? What about outside 192? 0 to that 2. Okay, guys, let me check in the background on the ASX if I have my FTD VM correctly configured. Looks fine. Okay, one thing. Let me show you something that might be important for you if you would like to run it on the ESX. Where's that information about interfaces? There is a table in the document showing the interfaces and how they are being mapped to the actual interfaces on the device. Oh, here we go. Yes, notice, and it was changed in I think 6.3 or 6.4. I don't remember exactly. The first interface that you have on a virtual device is actually the management. Then you have diagnostic, And then the third interface is the outside, or the geek interface, actually. I'm using this as an outside, see? The outside data inside. So the third one. And I have in my virtual device, I had that mapping wrong. So first is the management. The second should also be the management or anything else. Let me do that really quick. And third is the outside. Okay, and the next one is the inside. Okay, here we go. So I remapped. Yeah. Yeah, I can share that if you want to see the VMware configuration as well, no problem. Okay, I need to check how can I do this because that's the different screen. Is that guy? Oh, here we go. Right, so I have my FTD. Right, so the first is the management, then the diagnostic, outside, inside, then DMZ, failover, and so on. I only using 4 interfaces. I have 4 interfaces connected. Okay. So now, as you can see, I can ping the outside. I can ping the inside. Now, inside is pingable, outside is not. If I can ping from here. And that started working. What about outside? This is the ASA. This is the ASA 1. That one is ASA 2. It's not pingable. Check if I can do that from ASA 1. Yeah, easily. Okay, let me check the router from internet. Yeah, 116 that's 160. That's the 192.0.2.2. Windows. 192.0.2.10. E8, 7F, E8. I can do that from here. Yeah, that's exactly this interface. So I'm not really sure why I cannot ping it. Oh, that's strange. I see different IP addresses at the same MAC. To 18C. This is ATPF. That's the wrong. Okay, something is actually doing a proxy ARP here. Might be the ASA. Yeah, that's the MAC address of the ASA. See what's going on, right? I'm pinging 192.0.2.2, and the MAC address is actually coming from the ASA. It's not a MAC address from the router. Hmm. What is a NAT statement without no? Yeah, this is the NAT statement I have here for a NAT exemption for VPN, but shouldn't work like that. That's strange. ASA is responding to the ARP. Looks like this, but I don't know why. I can just simply stop the ASA, but that's not the case. I don't like that. ASA is in the HA. Maybe the IP address is configured somewhere. See this? 10.10.11. That's the okay. That's the inside. That's the okay. 192.10. That's 3. Yeah, so nothing here. I'm able to ping the outside of the ASA from this. So I can ping to that one, which is exactly this MAC address. But when I'm trying to ping to that 2, which is a completely different device, it's not doing this. And the ARP is showing exactly the same MAC address for both. Looks like ASA is answering with the ARP. Okay, let me do this. So I don't want to spend the whole day on that. Let's power off those ASAs for a moment. I will check that later. Okay, now it's showing the correct MAC address. So it had to be the ASA. I don't know why, because it doesn't. Mask. That's a good idea. So yeah, but the mask is okay. That's 24. Okay, now I can ping, so it's fine, but you know that was take a while, and I still don't know why ASA would do that. I don't see any reason why. Anyways, I can investigate that later. I don't want to waste time here. So now I can ping my FTD. Can I ping behind the FTD? I can't because of a NAT. I don't have that NAT. I would need to create one. So under the devices, I have a NAT config. And there's a question here, do I want to create a firepower NAT or threat defense NAT? So in this case, I'm looking for a threat defense NAT because I have the only device I have is the firepower threat defense. Call it NAT, assign it to my device, that policy. I'm gonna create the easiest NAT I can, which is the guys, but it's have some that is okay. Add a rule that's gonna be the auto NAT rule for not static, dynamic NAT for all 10 networks to the destination interface IP. But I need to specify the destination interface. So in zone gonna be the inside, destination zone is the destination object. Okay, so see this. This is the source interface. In zone, out zone for all 10/8. I'm going to translate to the interface. And the NAT config will be deployed. Okay, next week, I would like to spend some time talking about how to troubleshoot, how to see the sessions, and all that stuff. What is the difference between pre-filter and access control policy? Let me connect with SSH. I can. Okay. Okay, it seems like I have a too old PATI. I think I have a newer here. Okay, if I do show NAT, Now I see the configuration that was just sent from the FMC. I can do show NAT detail even more. So 10/8 is going to be translated to the interface's IP address. Now the internet should start working. Okay, cool. You should even be able to open some website. Oh, notice this, I have access denied. I'm attempting to access forbidden site, and that was because of this interactive block, right? So I need to click continue in order to do that. And then this is allowed. Okay, so that's how the interactive block works. Okay, so just wanted to make it working. Now let's spend some time talking about things like health policy and the platform settings. So this is about platform. Okay, actually, no, not really. Before that, I need to, okay, tell you that FMC obviously can manage different devices, right? We can manage next generation IPS, right, software, or we can manage next generation firewall software, which is the FTD. This is what we have in our lab, right? This software is still running on the old appliances or next generation IPS-V or ASA with firepower. Okay, a new software is the new platforms. So 1000, 2100, 4100, and 9300. Or NG Firewall Virtual, this is what we have in our lab. Or ASA as a hardware can be used to run FTD. Right, so two softwares can be managed with the FMC, but those two softwares are different from each other because the NG IPS is just a subset of NG Firewall. Right, NG Firewall, remember, this is the ASA with next generation IPS in the one software. So more features are available here. But that's why in some places in the FMC, you can find it a little bit confusing because there are some features for both, or there are some features specific to the FTD. Okay. For example, features for both are NAT, and that's why when I was trying to configure NAT, let me go back devices NAT. Right, if I click new policy, I have a question. Do I want to configure firepower NAT or threat defense NAT? The firepower NAT is the next generation IPS, old software, and threat defense is the newer software, next generation firewall. Okay, so NAT is the one place. Platform settings, a configuration like a banner, SSH access to the device, logging, stuff like that. It's also related to a particular software or VPN. You are configuring VPN, you need to decide, are you going to configure VPN for next generation IPS, the old one, or the new one that, and then the VPN the config comes from the ASA. Okay, but features only for the next generation firewall or FTD are those features that were coming from the ASA or came from the ASA. So QoS came from the ASA, pre-filter policy. We're gonna talk about this next week because I need to spend 1 hour talking about that. It's quite complex. Flex config, right? So everything that you can basically send commands like ASA configuration commands to configure something that you cannot configure from the GUI. Some objects are just related to the ASA or next generation firewall. Certificates and the whole, actually the PKI also. So those are the features related only to the FTD. For example, if I go to the devices and click QoS and I click new policy, I don't have that question. Do I want to QoS policy for this device or that device? Okay. But when I go to the platform settings, notice there is you can add firepower settings or threat defense settings. Okay, so you need to be aware of that first. Okay, now let me talk a little bit about platform settings and health policy. So platform settings is just a policy or a container for a config, which is a per device. So a policy or container for a per device config. Okay, so all config related to that specific device, like syslog, right? So syslog configuration, banner, that's gonna be displayed when you're connecting over SSH, or SSH access. So who's gonna have access to the device over the SSH, or HTTP access to it, or ICMP. Remember the ICMP permit outside? ICMP permit any outside. If you want to block, this is the ASA, right, command. If you want to block ICMP from the outside, you can do that with that config. Or some timeouts, like timeout for a session, like TCP session, all that stuff. This is the per device config. So you need to create a container, a policy, and apply it to that device. Good comment, Mir. Thanks. You'll see after those 3 meetings that we spent on the firepower, you see that how firepower is big and actually powerful, I would say. So you can then compare. Okay, maybe at the beginning there are a lot of information that you need to understand, but you'll see how powerful this can be. Right. What I wanted to show you, platform settings. So if I go to the devices, click the platform settings, I'm here. Right, I'm creating the platform settings for my FTD. So my device settings. Okay, I apply it to my FTD. Here I can add ARP inspection, I can add banner. Right. What else? DNS configuration, external authentication, fragmentation, HTTP, server, ICMP config, SSH, allowing SSH, syslog. The syslog is quite important. I'm going to enable login for syslog. I will select the login destination. This is going to be the internal buffer for debugging. Okay, and yeah, that's it. Time synchronization, I can synchronize with the management center or with a separate NTP. That's fine for me. I'm gonna save. And then deploy. Okay, device settings will be deployed. So let it deploy. And during that, let me talk about health policy. The health policy, again, is a container for health checks. Okay, you saw that this notification icon, it's changing, right? If I click health or health normal, which is basically telling me if something goes wrong or if everything is fine. If I see this green, that means all health checks are okay. So the green check means all checks are okay. There are two other options here. One is, how can I specify a different color here? Yes. Right. So the other thing can be this yellow triangle. The yellow triangle means there is a warning. So nothing really serious, but something to consider checking. And there is the third one, which is the red exclamation mark, which is basically an error or a critical alert. Okay, you can configure the health check policy when you go to the system health policy, and there is a default policy applied to all devices. If we go to the system, by the way, we don't have the system. We have the in that view, in this new theme, we have that gear icon, which basically the system health policy. And the health policy will tell me, or will tell the device what to check and report. And we have an initial health policy, and it's applied to 2 appliances. You may wonder, what are the 2 appliances do we have? Actually, when I click this icon, this apply icon, should show me the appliances. The one appliance is the FMC itself, another appliance is the FTD. Okay, yeah, now I see it. FTD and the FMC. And that's why it's saying applied to appliances. Okay, I'm gonna edit that to show you what are the different checks. As you can see, it's a quite long list. So what is more important? For example, the appliance heartbeat. That's very important because we are checking if the appliance is still up and running. But we can do the CPU usage check, which is by default off. But we can enable that and set some thresholds. What else? Disk status. This is reported. Disk usage. Hardware alarms. Interface status. That's quite important, but in the lab it's quite annoying because from time to time you're gonna see here an alert saying that some interface is not receiving any traffic, which is quite misleading, but this is a good check in production, because if some interface is not receiving any traffic, that means that something happened to that device or to that interface, or maybe to some device, surrounding device, that the traffic is not reaching the interface anymore. In the lab, since we don't have much traffic going out, then it might be like this, especially for a DMZ interface. So I will switch it to off. Right. What else? Memory usage, power supplies, things like that. Security intelligence. Is it, if we can download it or not? Time synchronization issues, stuff like that. Okay. So we can select what we want to our devices to report on, and save the policy and reapply it. So this is one of those policies that are not applied to the access control policy before being applied to the device. It's being applied directly to the device by clicking this apply button. We can now select the devices that this policy must be applied to. Obviously, I can create my own policy. I can create different policies per device. Depends on your need. So this is not the part of the typical deployment process. It's health policy. Check that on tasks. Being applied now. Okay. Okay, guys. So I think this is it. More on that stuff next week. So because I need to start talking about troubleshooting, about pre-filter, stuff that is quite extensive. It might be long to cover. I don't want to start now because that's a too big topic to cover. I need you to be fresh and ready for that. It was quite extensive anyway today, so yeah, we need to rest a bit. So I think this is it. I will deploy FMC and FTD in your pods. You're gonna have 6.5 FTD. I expect that to have maybe on Monday. I will be deploying that tomorrow, so it will take maybe 1 day because each device is like 40 gigs. So yeah. A message. Oh, okay. ASA2. I will check that and let you know, or it should start working if it doesn't. I will check that just after this meeting. Okay. Right. So I think this is it, guys, for today. Right. I hope that was informative, even though there are a lot of acronyms and hard stuff to cover. But I hope you guys enjoyed that class and today's meeting. So thank you very much for being with me and have a great rest of the weekend. Okay. See you next week and cheers. Thanks. Bye.